Okay, second day for our Agentic AI conference. I'm Raja Iqbal. I'm going to be the moderator for today as well. I will go over the agenda and the overall what we plan to do in today's agenda. So first of all, thank you everyone. We had an overwhelming response for the conference. We had close to 66,000 registered attendees from all over the world. And once again, a quick shout out to our partners who have made this conference possible. And today's agenda, let's really quickly dive into today's agenda and also what's going to happen on day 3 through 5. So today we have 6 tutorials. Each tutorial is about 50 minutes. And the idea is to have very quick hands-on tutorials where you can actually learn something, actually build something in a specific area of agentic AI. And then day 3 through 5, those are our paid workshops. They are already sold out. They are half-day deep dives into specific topic and something more detailed than a tutorial, about 4 hours each. So let's do a quick recap where we are. Yesterday we started with how do we actually design intelligent agents? We talked about the planning aspect of agency, the idea of memory, the idea of reflection. So we talked about we had the first 2 panels were around the discussion around planning and how do you organize, self-reflection, planning, and so on. And in the third panel on MCP, we talked about the general issues and the challenges in deploying model context protocol servers. And then we had 2 tutorials where we saw all of the discussion that happened in the first 3 panels. We took a deeper dive into actually implementing those. What would a real system look like when you actually build a multi-agent system? And in the last tutorial, we actually saw an end-to-end platform where we were able to see, well, what does a guardrail look like, and what does evaluation look like, and what does a multi-agent or an agentic framework, what does that look like? So we did go through some of the challenges when you deploy these systems. We looked at some of the challenges, and then we also looked at what was the end product. Once you go through all the challenges, what does a product look like? So today we have a full agenda. We will start with a tutorial by Landing AI. Andrea Kropp, she's going to present to us, the agentic document extraction with Landing AI. And then later on during the day, we will have a variety of topics, right? So the second topic, for instance, that is on GraphRAG, and GraphRAG is essentially so when you build a RAG or retrieval augmented generation based system or an application. There is a challenge around hallucination, right? So and GraphRAG is actually empirically it is known to improve or mitigate some of the hallucination aspects. Then we will have I'll keep going here very quickly. If you're looking at if your modality of the input is instead of text, you're looking at some image-based agents if you're building those, and then what if you want to build a research assistant, and if you want to connect your agents with GitHub using webhooks, and build more agentic workflows. So we have a full agenda here, and we are going to, it's the day should be full of learning. Just uh, hang on, and just we'll have 10-minute breaks in between. I think you should learn something very meaningful here. It's the way we have designed the conference, the way we have structured the conference is that we want to make sure that everyone who is here, they leave with a lot of learning. Okay, so I think I have gone through the tutorials, the overview of tutorials. I mean, this is our first session that will happen immediately after I hand it over to Andrea. Then we have a few more tutorials. I will flash them on the screen a little bit one by one so you can see what is coming up. And here, I think this is the last one. And then for those of you who are interested, everything that we are doing here and everything that we are building, if you want to learn all of this in a short span of time, we have this Agentic AI Bootcamp. It's about 30-40 hour of training, which actually covers all the aspects, and go check it out. The QR code is there. Just go check it out, and that should be it. I will hand it over to Andrea. I saw, Andrea, you are here. I will hand it over to you.
Yes, good morning, everyone. Thank you, Raja, for the introduction. All right. Good morning, everyone. Thank you for the introduction, and thank you to Data Science Dojo for having us here today. Let me go ahead and share screens. I have a lot of content prepared for you, so we're going to get right into it. So I'm pleased to be here today to talk to you about document understanding and how to extract accurate insights from documents using some of the tools that Landing AI has built, but also some of the fundamental agentic concepts behind what makes this possible. So if you're not familiar with Landing AI, we are a pioneer in enterprise AI that really takes a vision-first approach to everything that we do. So we do work with JPEGs and PNGs, like our foundations are really in the vision space. And so we're treating documents as if they were pictures. And this is really allowing us to bring kind of breakthrough performance to the area of document understanding by treating them as images first. You may know our founder and executive chairman, Dr. Andrew Ng. He is highly involved in everything that we do, brings all of his deep expertise and connections to the technologies that we're able to develop. So we're very fortunate to have him. And we have a very strong user base with about 1 billion images and documents processed so far. A little bit about me. I've worn a lot of different hats in my career, from consulting to leading technical teams and technology sales. I'm entirely self-taught as a data scientist and MLE. I originally studied chemistry. And if you ever run into me on the street, I would gladly play some tennis or some board games with you. I should mention that I'm joined today by my colleague, Ankit Kara. He is going to be manning the chat and is able to answer questions during the session, so feel free to post your questions. All right, brief agenda today. So we've got about 50 minutes, already down to about 48. So we're going to talk about what's hard about document understanding and then get immediately into our agentic approach to that problem. We will spend some time actually looking at some of the Landing AI tools in the visual playground. I'll show you some extractions on some very difficult documents, including multilingual, handwritten, archival documents. And then we'll start to apply some standard schemas to those documents. In addition to doing some visual examples, I'll introduce you to the REST API and the Python library where you can get started. And we'll do two fun demos, one dealing with utility bills and one dealing with some product images. And Ankit should be pasting in the chat a place where you can kind of follow along with what I'm doing, drag and drop some of your own difficult documents into the visual playground. We do ask that you use that tracking link that we're providing so that we understand kind of who found us through Data Science Dojo. So would appreciate your cooperation with that. Yes, should have advanced to the next slide. So we do have this tracking link to get access to our visual playground. This is entirely free to create an account, and also our Python library and documentation will take you through how to make best use of those resources. So if you have ever tried to parse a document to extract specific information from it, especially if it's rotated, handwritten, has coffee stains on top of it, was photographed poorly, was scanned poorly, you know that there are many different challenges in document processing. So typically, you know, at a hobbyist level, maybe you can work through some of those challenges and you don't have that many variations to deal with. But at an enterprise level, you have to really build a robust pipeline to deal with all of these edge cases. And that just leads to really slow processes. You know, we talk to teams that are taking months and months just to build up a pipeline, do some layout specific training on their complex documents, deal with all of these edge cases. And so it just tends to be really slow. Even when working, it often delivers very inconsistent results, right? I've already mentioned, you know, documents that are damaged, but what about, you know, information that's spread across 2 pages? So you might have the, you know, name of the person on page 1 and the account number on page 2. Lack of traceability, of course, is becoming an issue with the advent of large language models, large vision models. Are they hallucinating? Is this grounded in fact? How would an end user know which of those is the truth? And of course, all of this leads to still a lot of human in the loop and a lot of human review. And if you were going to have a human review every document anyway, then like, why did you build this whole pipeline? So those being some of the challenges, the demos we're going to look at today start to get around some of those issues. So one example we'll do is we'll look at some utility bills. So over here on the left-hand side, I have some nice, clean digital utility bills, but they are from 2 different agencies, and so they have vastly different layouts in terms of where is the date, where is the total amount, right? Like there's some interesting circles and things going on. And then to the right-hand side here, we have some photographs of utility bills. So, you know, one is filling the frame, the other isn't. It's maybe rotated 5 degrees. Of course, they're from 2 additional utilities besides the first 2. So how would you at scale actually extract standardized information from this? So your basic, you know, name, account number, location, like number of kilowatt hours used. And how would you actually assign a confidence score associated with each one of those extractions? So this is kind of what we're building up toward. And then we'll do another example with product labels. So as I mentioned before, we are a vision-first company. We come from the vision space. And so we're treating documents as pictures. And for that reason, we also work very well with like text that happens to be on pictures. So this is a fun demonstration. You know, every product in the grocery store has completely different labels, different fonts, different layouts. And what we're trying to extract here is kind of a standardized table to say, you know, does this product claim to be dairy-free? Does it claim to be lactose-free? Does it claim to have no added sugar? And you could go through a long schema of specific product claims applied to a set of images. Okay. So how does this all work? What's the agentic component of this? So I can't give away the secret sauce, but I can give you some orientation to the platform and the orchestration. Now, today we're going to take mostly an applied perspective and actually see how to apply the agents that are available to you. But these are some of the things that are happening under the hood. So at the UI level, we'll be working a fair amount in our visual playground, which is available here. That's that tracking link that we posted previously. And you can also interact with all of our tools through our Python library or our REST API. So a couple different user layers. Then the reason that the domain here starts with va.landingAI is this is our vision agent. So VA stands for vision agent. This is the orchestration layer that actually brings together all of the tools that the agent has access to. So within that, there are multiple specialized agents, right, for planning, for judging, for doing the code. And then those agents have access to a variety of third-party as well as proprietary tools. So, there's lots of other great tools being discussed today. So I'll kind of skip ahead to some of the proprietary pieces that we bring. Um, Without sharing too much about all of our proprietary models, we do have two that are really foundational to making something like that utility bill example or those product labels work. So one is what we call our layout model. So the purpose here is to detect, classify, and number the chunks in a document the same way that a human would. So we'll see shortly, purple for us is anything that's a margin. Green is anything that's a text block. Blue is anything that's a table. And these will also be numbered like 1, 2, 3, 4 in kind of the human reading order. So there's a layout foundation model that actually detects these chunks and the numbered layout. And then we have a table model. So tables that are already in pretty rows and columns, not a problem. Where we start to get problem is when nobody bothered to draw any lines on the table. So this image right here, actually a human would recognize this as a one row table. So there's something like part number and description right here. It's like the rear shock absorbers. So this is actually a table header row and then one line item entry in the table. And then there's some other key value pairs down here below, like country of origin, Thailand. And traditional OCR systems really struggle with something like this because there are no visual guidelines to understand that this is a one row table as well as about 3 key value pairs. So this is some of the proprietary technology that we make available to the agents. And then with the orchestration layer, bring kind of that power to you here in the visual user interface. I'm just going to go through a couple more slides. I know we all want to see some code. The code that we're sharing today is also available on our GitHub. There's a couple YouTube videos of me doing very similar demonstrations. So we'll get into the code here very quickly. So the couple highlights here. We want to be able to process complex documents without any sort of layout specific training. This is an accident statement. It's got vehicle A on the left and vehicle B on the right, and it's got some checkboxes down the middle, and it's got a place where you can draw exactly how the accident happened. This type of document would be just a disaster to do any sort of layout training on. So we want to be able to use an agentic approach to detect this layout automatically. The fact that it appears in 3 columns, what is the human reading order, what is the data associated with vehicle A, associated with vehicle B through kind of chunk references, and then be able to turn that into, something that an insurance agency or a police report could extract directly. We're going to get developer-friendly JSON out of everything we do, so we don't want to be exporting some sort of strange proprietary format. So you're going to get everything in nice hierarchical JSON. And then we get to the visual groundings. So going back to the chunk reference model, the table, the layout foundation model. I'm going too fast this morning. So the layout foundation model is going to return these identified chunks, right? Something like this logo is going to be detected as a figure. And for each of those, you're going to say, okay, this appeared on page 0, which of course in Python world is page 1. And then the bounding box coordinates relative to the entire document. So when when we pull information out of that document later, we can always refer back to exactly which chunk it appeared, and we could show a human in the loop exactly where on the page that appeared. And then some schema extraction. I think this will make more sense once we do it, but being able to extract things like date of accident, witness name, vehicle A, insurance company, be able to define that schema once and be able to extract it repeatedly from multiple documents. Okay. Let's switch over to the visual playground. So here I am at va.landing.ai. This is that exact document that we saw in the slides. It is one of the example files that'll be preloaded if you choose to create an account. It's this one called accident statement. So this experience, we call this our visual playground. To actually interact with our agentic document extraction, you are going to call that through the REST API or with the Python library. But the visual playground is a really great place to actually check, like, are the extractions correct? So for example, we talked a little bit about the reading order. So here's chunk one, there's another chunk, and so on and so forth. And it's a great way to drop in your difficult document and actually kind of quickly check, like, is the extraction coming through correctly? This is a great one just to emphasize things like checkboxes or circled fields on forms, things that traditional optical character recognition is really going to struggle with. But how do you use this with your own documents? How do you get started? So let's do those utility bills that I promised. So you're going to see me kind of dragging and dropping things from off screen. Here's one of those utility bills. It's the orange PSNG. So this is now being sent to our API. Again, that agent behind the scenes has access to the foundation model, the table model, other proprietary tools, and other third-party tools to return this extracted result. So this is 4 pages. So in the visual playground, we can tab through all the pages. It looks like our final chunk was number 54. Might be a little bit past there. No, number 56. So we have this document now has been parsed into 56 chunks, and each of those have been identified as something like text or figure or table. All right, let's do one more. Let's drop in the photographed version. So this has a few more difficulties associated with it, right? It's a photograph, there's some wrinkles, there's some rotation, but we do actually have all of the fields that we want are visible. So again, we've got, let me overlay. So we've got a variety of different chunks. Anything that's pink is a figure. Anything that's blue is a table. And this visual interface gives you a nice chance to actually verify the accuracy of the values in this table by kind of zooming in and out. Okay, so I promised that this would be mostly an applied session. So this is ready for you to use. This kind of agentic workflow is going to work really well on a wide variety of documents. So I'm just going to take you through a couple examples just to kind of get your kind of creative juices flowing. So this is a fairly simple example on prescription for glasses. I wear glasses. Lots of people I Zoom with wear glasses. And another great example of kind of checkbox extraction. And of course, you know, if you imagine you're a business like a Costco, right? Like you're fulfilling prescriptions all day, but they look very different, right? So this prescription looks very different from this prescription, but they fundamentally have the same information on them. So we're going to be getting to how do you actually standardize that into some standard extractions. And here's a nice example of the circling. This is one of my favorite documents because it just has so many different things going on. 18-page equity research report. And I'm just going to scroll ahead to a couple of the chart types. So, I've got some basic pie charts, bar charts, horizontal bar charts. It gets more interesting as we go on. Some tables, some spider charts. Um, so this document, on average, the parsing takes about 8 seconds per page. I should say is the median, not the average. So an 18-page document like this might take about a minute to get back this type of results. But it's absolutely amazing to be able to get results from all of these complex figures and layouts in one shot without having to do any sort of layout specific training. So this is a great example for a well-formatted digital document that just has a lot of different types within it. Here's another kind of scanned document. So something like certificate of origin doesn't really have clear, obvious sections. Mostly we're probably interested in the table being extracted here. So what are the products being shipped? We've got some, cartons of footwear. Um, and something like this being extracted as a figure, we're actually going to be introducing some additional figure types soon to detect signatures and stamps and QR codes as their own separate types. So that's going to be coming soon. As we're starting to get international here, and because I previewed some of those food labels, the agentic system works really well multilingually in multiple languages. So in the slide I showed in terms of kind of the tools that the agent has access to, we didn't really talk about which languages or any sort of translation. But this is kind of a fun macaroni package that has multiple languages all on one package. And again, would invite you to drag and drop some of your multilingual documents and then actually check the extractions on those. We got a little bit of German handwriting. We've got some more archival documents. Some of these getting, really, really difficult to read, but something like, occupation farmer, birthplace, Pennsylvania. So this document is both handwritten and poorly scanned. And then this is the last example before we go do some code. This one I thought was kind of fun because like somebody just wrote this like text New York City on top of this document. This one also has some kind of water or other damage, right? So if you look over here at, this is like Reginald Bolton, and I think the name below, to a human would probably come out as Nicholas, right? And that is being extracted properly here as well. So a lot of archivists and historians have gotten really excited about this, or even if you're just doing it as a family project to turn kind of family records into digital assets that can be preserved and passed down. This kind of damage on the side where things are not quite clear actually comes through quite clearly. Okay, I got to be aware of time. We got to go do some code. So let's start with the electric bills. Okay, so everything you're going to see here is some really basic data science libraries. So you can pip install our Agentic Doc library. You will need an API key, which you can get from the Visual Playground, and our docs are all entirely public at docs.landingai. So here we're going to import parse. And I wound up actually not using Viz document, so I'll let you refer back to that in the documentation. So in my case, I've set my API key as an environment variable, and there's some other things you can set in your environment variable over here. So the API is able to handle 100 documents in parallel. My batch size of 25 means I'm going to be working on up to 25 documents at once. And max workers 4 means there can be up to 4 pages within each one of those documents that can be worked on simultaneously. So there's a lot of built-in parallelism here. For something like electric bills, these settings work pretty well. because most of the bills are not more than 4 pages, so I can work on 25 of them simultaneously, assuming very few are more than 4 pages. Okay, these are the input documents we're going to use. So the same two that we saw in the visual playground, we're going to start with the digital electric bill and the image of the electric bill. And this is about as simple as it gets. So we're going to say we want to parse. Right now we only have 2 documents in our file path, and we want to save some of those results locally. So I'm going to go ahead and bring that on screen. And you should see some things populating in our groundings and our results folder. And I'm going to, as soon as I execute this, it's going to be in the foreground. Oops. What did I click? Oh, there we go. Okay. All right, so my API key is valid. We're working on both documents simultaneously. Here's the results folder. So we probably got back the result from the 1-page picture slightly before the 4-page PDF. But at this point, we have back that same JSON response that we saw in the visual playground. And I'm actually just realizing I never showed you the JSON results in the visual playground. So here we have all of the different chunks, the text associated with that chunk, the bounding box, and also the image reference for that chunk here on my local system. So if we come back here, in our groundings folder, we now have all of these individual pieces as individual chunks, each with their own chunk reference and ID. So in about 11 seconds median per page, we're applying the chunking strategy, extracting all of the information from each chunk, whether it's figure text table, and then returning those all as visual groundings. Of course, we can print a few things to screen. And here are all those different chunks that we saw in the visual playground. Okay, let's go back to the playground for the field extraction. Okay, here was my, okay, so let's work with the digital one because it's just a little bit easier to see on screen. Okay, so we've done the parsing. I did entirely neglect to show you the JSON in the UI. So the JSON in the UI also has the nice feature of like if you click around in the UI, it'll show you the JSON that corresponds to that. But at this point, we're done with parse and we're going to move on to extract. So in this utility example, right, if I'm kind of doing identity verification or address verification, like most of you have probably been asked to submit a utility bill as like proof of address. So the organizations that are receiving all of those, like they're interested in actually pulling out your address and matching that to whatever you stated on your application, right? If you've supplied this as a proof of address. So let's start with like, how do we pull all the addresses out of these types of documents? So again, this visual interface is for your convenience. You can build this schema any way that you want. But if you start from scratch, you can simply like add a field that says, service address. And the more description you provide, the better the results will be. Providing the description is very much like prompt engineering. So you may say, I want the address formatted in a certain way. I want it with or without PO boxes. But as a very simple demonstration with just service address and no description, the agent does understand what I want out of this document. And in addition to returning the answer, is also returning the chunk references. So this address must appear in at least 2 places in the original document. And again, this is going to line up to those chunk values that we saw in that folder when we broke the document into the individual images. Okay, let's go ahead and start over. So if you know exactly what you want, by all means, build it up one at a time. You can also start with suggestions. So this schema was automatically generated based on this single document, and then I can run this schema. So with something like this or with like the eyeglasses prescriptions, it can be really helpful just to run the automatic schema generation on the document, see what it suggests, what it comes up with, and then kind of modify it from there. So we do support two levels of nested schemas here. So you can see within gas charges, there are some, breakdowns such as the meter number or the usage, and within like important dates, there are these dates, and important dates might not be the way that you actually want your final schema, but it certainly allows for quick testing to understand, is the model getting these things right? And you've got all the chunk references that go along with it. The last option is going to be to upload a schema. So I actually had one, if I spell utilities correctly. There it is, utilities. So you may have seen this open in VS Code. This was on one of the tabs. So this is a schema that I prepared outside, and I can now import it on this document and see kind of how that's performing. So this is that JSON schema. It only has a couple required objects. So like customer name, account number, we've got the address. And then also just noting that you can do things like Booleans to say like, what has it got down here? The description is like, does the utility bill include a chart depicting usage trends over time? And it's set as a Boolean, and so that comes back as true. So once you've got a schema that you like, you can request the code for that directly to use with the API. So again, whatever schema you have in the foreground here, we offer it either as a Pydantic or as JSON. So I'm going to go ahead and just copy all of this. And I'll come back over here. And my next cell says paste Pydantic schema from Visual Playground. So we just generated this. I'm going to go ahead and paste it in. I do know that down at the bottom, I need to change this to one of the actual documents we have. So we'll just send the first one. And then let's go ahead and do that. So one thing to note, right now we are actually parsing the document a second time. So we did previously parse them in the cells up above. We are now parsing it again. So we're going to get different chunk references, and we're applying our extraction model. So a lot of people have asked us, can I parse once and extract many? The answer to that is yes. Dr. Ng is actually going to be making an announcement about that next week. So I'm not including it in today's demo, but we will be able to parse once and extract many times against that markdown file. So this is looking pretty good. So we've got a name, an account number, some of the fields that we asked for. So this was using Pydantic. So you can learn more about Pydantic from their documentation. Right now we're supporting one level of nested schemas. So this is using Pydantic, which you can learn more about. And then you can also paste the schema as JSON. So these are two different options. I'll go ahead and run this one as well. And again, now we're oh yeah, so that was just applying the schema. And here again, we're parsing the document now a third time, which of course is kind of unnecessary, but this is just to demonstrate the JSON schema. So you would send that this way. So all in all, actually really very easy to use. And then the next part of the demo here is we want to apply this to a larger set of documents. So let's go back to my folder. So in input folder 2, I've got a couple more of these, so a total of 9. So this is really where we can start to take advantage of some of the parallelism. So 9 different documents. Here we're going to send them with that extraction schema. And then the goal here, of course, is to put them into a nice, tidy pandas table and then be able to insert that into a database, save it locally, whatever you want to do with that structured data. Okay. Time check. Okay, I think we're doing well. Let's let this run. I'm going to show you a few more examples in the playground. Also, exactly where to get some of the reference information. Hopefully, many of you have already used the tracking link to create an account and are starting to drag and drop some of your own difficult documents. But let's talk a little bit about figures. So, we've spoken a lot about field extraction and the desire to pull out structured fields like addresses, account numbers. But the other key workflow for something like this is a RAG pipeline where you're actually able to like refer back to, say, scientific documents or product manuals or like engineering failure reports. And what's unique about those types of documents is they often have figures included in them, and the figures are often a very rich source of the information. So just a couple things to demonstrate performance on figures. So I did some searching for some really kind of unique, one-of-a-kind figures. Say like there's no possible way that a model has been pre-trained on a figure like this. So I found this one quite interesting, right? So the main message here really is embedded in the figure. Like you have to look at the figure. You have to look at the icons. You have to look at the direction of the arrows. You have to understand the map in the background. And there's a lot of richness in this figure relative to like all of the text that surrounds it. So we've really put a lot of work into the figure extraction for your downstream RAG pipelines to be able to surface information that came from the figures within a document, not just the text. Right. So obviously I'm not going to read all of this to you, but understanding that like this is the meaning of the blue circle, this is the meaning of the pink arrows, and even kind of a high level analysis of like what does this figure show? So it's the 2 main domestication centers for taurine cattle in the Near East and Indocene cattle in South Asia. So when you take a chunk like this and put it in your downstream RAG pipeline, and you have this particular figure has been excerpted as its own chunk, you can now return information from the figure as part of your RAG response. Here's another example with figures. I guess I was on a cow kick one day. But what I like about this one is it emphasizes that relationship between individual chunks and the whole page. And I'm not explaining that really well, but take a look at here, just this brown Swiss. So this gray number, 4.1%, within this chunk is actually completely isolated information. Like it's not clear what this 4.1% is. The only place that this is actually clarified is in this other chunk, which says that gray is average milk fat. Right. And so, a middle school student, high school student could probably figure this out, say, like, what is this 4.1? Like, oh, the gray means average milk fat. But this is actually very difficult for an LLM or a RAG system to understand without actually providing the direct text. So notice in this chunk number 6, now I have 4.1% milk fat percentage, right, which is bringing in the information contextually from this other chunk to understand what does this 4.1% actually mean, or same with this 3.5 down below. So This is kind of the agentic nature of this system to be able to provide understanding within these figures, drawing from other things on the same page, but also other pages. So in this case, the key was on the same page, but it could have also been on a different page, and you would still associate that correctly. This is one of my favorite examples. So IKEA does a lot to provide visual instructions with very little writing, right? It allows them to be highly international. But if you take an example such as this, it says the illustration visually instructs users to always assemble objects on a protective surface to prevent damage and not directly on hardwood floors. And that is exactly the meaning of this, right? It's not just a description saying there's an icon on the left with an X on it and an unhappy face, and an icon on the right with a happy face. Like it actually understands the ultimate meaning of this. So put something under your assembly. And ending on a more serious note, this again is a scientific paper. We do a lot of examples just with the common cold because it's helpful. This is a nice example where a table actually breaks the main two-column layout of the document, but you can see that the bounding here is correct for those. But I actually wanted to draw attention to some of the figures. So if you look very, very carefully at these figures, there are actually arrows that are pointing at the different pieces that they're kind of trying to draw attention to, right? I'm not a radiologist. I don't really know how to interpret these. But in this whole section of figure analysis and being able to put figures into a downstream RAG pipeline, again, in the analysis here, the figure is designed to highlight differences or similarities in the ethmoid sinus region between two conditions in the same subject. And then it specifically highlights the arrows. So the arrows direct attention to possible changes in tissue density, structure, or pathology. So the ability to pull these images along with this rich explanation into a RAG system, super, super powerful. And also not having to send your text one place and your images another place. Okay, let's finish up with this. Should be all done by now. So we had 9 different documents to parse. Again, here we're just printing a couple things to field, printing a couple things to screen, right? So in this case, the field extraction was new. So we have the fields, and we also have the metadata associated with those fields. And we can end with importing pandas, listing exactly the pieces that we want, and pulling that into a nice structured table. Obviously, not a big deal to save it. So this is kind of demonstrating sending 9 documents that all fundamentally have the same information and then applying this extraction schema. This last cell pulls out the chunk references and the confidence scores. So the chunk references, again, are going to allow you to surface for a human those particular segments of the document. And you might choose to do that in response to the confidence score. Confidence score is still somewhat experimental, so you'll see it marked as beta in the documentation. But you can imagine something like this, which is, starts with a 0.8. You could create some sort of a slider that says, if the confidence score is below 0.9, like let's show this chunk to a human and have them verify that this is the correct extraction for the account number. And then anything that passes that is above that confidence threshold can just flow automatically through the system. All right. I think just for fun, we'll do the food labels and then we'll call it a day. So you saw these at the very beginning in the slides. These are the specific images that we're going to be sending. So food labels with a variety of health claims. So whether it's grass-fed or organic or non-GMO or, whatever else is on here, healthy. I'll just go ahead and just run this whole notebook all at once. It fundamentally follows the same process as the previous one. So we define where our files are coming from. We do offer several upstream connectors, like for S3 or Azure Blob Storage. So I've been doing things locally, but there's lots of connectors available. Here are my JPEGs. Um, Here's a look at the extraction schema in Pydantic. So this is really the place where you want to invest some time. So something like, is grass-fed? It's a Boolean, like true if the label mentions grass-fed. Um, is regenerative. I don't even know what that means, but it's true if the label includes terms like regeneratively sourced or certified regenerative. So the more effort you put into the descriptions, the higher quality results you're going to get. And it looks like all of this is done. We can convert this all to a table. And here we have the, extractions and all of our health claims. So is it lactose free? Does it have antibiotics? Is it USDA inspected? I only included a couple of the chunk references because that gets kind of clutters up the table. But I think you get the idea with that. Oh my gosh, that's my crazy desktop. We don't want to see that. Quick, hide that. Quick, hide that. Let's go back to where are my slides? Uh, there we go. That's better. Um, so let's end with taking a look at the API and the library. So if you've been following along, hopefully you've tried some documents in the UI. Over here in the key in the lower left, you can access your API key. And you can also access the documentation. So Landing AI, we offer a couple different products. If you're not in the right one, look here in the drop-down menu. You want to be in Agentic Document Extraction. And then note that this is information for the Visual Playground, for the REST API, and for the Python library. So I find that people don't always realize that these are three different sets of documentation. So on the playground, super intuitive, but if you need instructions, those are here. You can call the REST API directly, so with Python curled JavaScript, and just pay attention to some of the notes here for what you need to do differently if you're sending a PDF versus sending some image format. And then I guess going back to the Python library, unless you have a reason to be using the REST API, we would strongly encourage you to use the Python library. It has those parallelization and auto retry features, which the REST API does not have. There's some more information here about how to kind of maximize parallelism for large workloads. So you saw me refer to that a little bit with the environment variables. And then this is going to take you through all of the details including a few different options for how to set your API key. There are no maximums on using the Python library, but you will find that the visual playground has a 50-page maximum. So no maximums here in the visual UI. You'll run into that 50-page limit. And I guess I'll just close out with a couple kind of great use cases. And then I know that Ankit's been answering questions along the way. You can ask me one or two questions, and then I'll give you 5 minutes back before the next excellent presentation. So we're working with a lot of financial services companies. So because we are really emphasizing accuracy and visual grounding, this has been kind of fruitful territory. So if you need to analyze identity documents, pay stubs, invoices, anything along that lines. Healthcare has been an excellent application of agentic document extraction. So if you think about there've been the move toward electronic health records, right? So you can bring your health records from one provider to the next provider, and then you move out of state or out of the country, and you can bring those things with you. But often like the information in the figures is lost, right? Or like some of the checkboxes or the forms are lost. So the ability to actually have these rich extractions from medical histories, super valuable for patients and providers. We saw this example from shipping and logistics. This segment generates a lot of paper, so bills of lading, certificates of origin, customs declarations, lots of paper involved in shipping and logistics. And then you also saw me mention kind of archival and library science applications where every document is one of a kind. So there's really no such thing as layout training because they're all one of a kind. So hopefully that gives you a couple other ideas for what you could do with something like agentic document extraction. And hopefully I have convinced you that you're not going to run into as many of these challenges as in the past. So we're trying to provide something that's fast, accurate, traceable, and efficient. So basically the opposite of all four of these. So let me stop sharing there, see if there's any questions that Ankit would like me to address, and otherwise I'll give you 5 minutes back or give you 5 minutes to actually go try it.
So, Andrea, so since you have 4 more minutes, maybe I can look at some of the questions and send them your way that I also find interesting.
Yeah, let's do that.
So I think I will combine the two questions. Maybe you already handled those, but how do you handle sensitive data like PII, etc. within?
Yes. So we do have a security page. If you go to our website and go down to the footer, you're going to find the security links. Um, we are HIPAA compliant. We do have SOC 2 and we are GDPR compliant. We offer a service called zero data retention, where the document is basically ephemeral. So we use it for processing and then immediately discard it, as well as any sub-processors that we use are immediately discarding it. So we have been able to work with those healthcare and those financial services companies after they've reviewed all of our security and privacy. So all of that's available on the website for you to review for yourself as well. And I'll just drop the link in the chat.
And I think there is one more question about, maybe if you want to take it right now, right? So about the subscription model, uh, there is a question by Shankar about how how do we use it and what is the subscription and pricing, etc.
Yeah, I'll drop that
Maybe
in the
Ankit
chat.
can drop
I'll
a
drop that
link.
in chat as well.
Yeah.
So all of this is super transparent. So when you create a new account, you'll get 1,000 free credits. Those 1,000 free credits will allow you to do like probably close to 100 pages just to test things out. And then we operate on a credit-based model, and like different services that you use have different credit values associated with them. So parsing is 3 credits, field extraction is 3 credits, and then the zero data retention is 1 credit if you need that for a sensitive document. So it's very common to either have 3, 6, or 7 credits per page, or like the most common usage schemes.
Okay. So it is by page then. And so there's a question related to the same, something along the same lines. How do we handle bigger PDFs? Because I mean, I know firsthand some services they crash when the PDFs are huge, right? So how do you can it handle any number of pages in PDF? I think that is the question that I see here.
Um, So you'll see in the documentation it says like 1,000+ page PDFs. I don't know that anybody's tried like how far you can push that plus, but I'm gonna say like up to 1,000 should be fine, and then like let us know if you push too much past that.
Okay, and I think that is about it. I don't see any other interesting questions. Okay. Yeah, I think a lot of the multiple questions around GDPR, HIPAA, PII. So, we have addressed those. Sensitive data, more questions. Yeah, I think we are, that should be about it. And we are right on time.
All right, thank you so much for having me. Thank you for the questions, and have fun extracting some difficult documents.
Thank you so much, Andrea. And thank you, Ankit. I know you're there. So thank you so much.
Thanks, folks.
Thank you.
See you later.
Same. So we are going to take a 10-minute break. We are going to come back at 10:10 a.m. Pacific time. In about 10 minutes, we'll come back and we'll move on to the next tutorial. Okay, so our next speaker is from Neo4j, Alison Cosset, and she is not here yet. We are trying to get in touch with her. So what I'm going to do here is, let me... So what I'm going to do here is, so just in anticipation, what is coming up, we are going to see here. Okay, so, okay, Alison is here. That's great. Hi, Alison.
Hi, Raja. How are you?
Doing well.
I have a new laptop, so I don't know if you can see me today or not. Is my camera working?
No, I cannot see you actually.
No. All right. Let me see. Hold on 1 second. Let me reset something. Is this gonna work? Nope. All right. Well, I apologize. It's the new Zoom. It's the new update, so I apologize about that. But if you're okay with me going without a face, which is not how I prefer to do things, I can certainly get us started today.
Yeah. Please go ahead, Alison. I will hand it over to you. I will go off camera, but I will be here.
Sure. All righty. So let me take us to where are we starting here? So many windows, so little time. Hold on 1 second. Hold on. You know how it is whenever you get it's the first day with the new laptop. So my deepest apologies to everyone. To let you know a little bit about who I am, my name is Alison Cosset. I am here with Neo4j representing our workshop today. So let me see, here we go. Here we go. All right, so hopefully everybody can see everything now. I am here with Neo4j, and I am going to be walking you through how we get structured data and unstructured data into a GraphRAG system so that you can run your agents. So what I have available for everyone, the good news is, and what's pretty exciting about Graph Academy is at Neo4j that we have a ton of free courses that are available and free workshops. This workshop that I'm walking you through today is usually 2 hours. So I'm going to give you the compressed version, but the good news is that this workshop will be available to you at any time. So if you want to go to the URL and run this yourself, it's going to be graphacademy.neo4j.com/courses. And the name of the course is Workshop-Gen AI. Can everybody see my screen okay? Raja, hopefully you can. And what we're going to be
yes,
doing.
we can, Alison.
Excellent. All right. So again, so all of this is available and it's free to you. We're kind of giving you a little bit of the compressed version today, but what I'm going to do is I'm going to walk you through all of these pieces. So to tell you a little bit about what we're talking about, many people have, and I'm actually just going to, you certainly don't need me to go over the basics of what is Gen AI. Obviously, everybody here is perfectly familiar with that. But what I do want to talk through is I want to talk through a little bit around the model. So we clearly know that when we're working on RAG applications and we're working on agent applications, we're really trying to, in our case, use how we can use data to improve what's coming out of the language model. The way that we do this in our instances, what I'm introducing you to today is a knowledge graph. So the knowledge graph is actually built based on nodes and relationships. So when we think of how RAG works and what we're grounding in, what we're going to be grounding in today is not just, everybody's pretty used to a vector database. What we're going to do is we're going to expand that concept of the unstructured and vector database and expand it to include your structured data. So some of the basics about graph are we have nodes and relationships. So you can think of it like if you've got a table of people and a table of company. In our case, we're working with SEC data today. So we have a table of asset managers and we have a table of companies, right? So these asset managers own shares in these companies. In a traditional relational database, you would have probably a lookup table that would have the name of the asset manager, the name of the company, and then some parameters. So they own a certain amount of stock at a certain point in time. And so in general, the way that you can think of the relationship, not to use a relationship, but the connection between relational and graph is if you've got a lookup table in your ERD, in a graph, that would roughly be what we call a relationship. So those elements that are on that table would then be properties on the relationship, which is what we have here. So just to give you a little bit about that, I know everybody's looking forward to learning another language, but the language that we use to query the database in Graph is called Cypher. The good news is we have a very clear, consistent format around that language. Much of it is very similar to what you'll see in SQL, right? So you have a return statement, select from where, but rather than that, what we have is we have match and return. So what we're looking for is we're looking for patterns in the relationship. So if historically in SQL, you would say, from asset manager, join lookup table, join company, and you would have this very complex piece. In our case, we're saying, just match me the asset manager who owns companies. In this case, we're saying the asset manager is Andre, the asset manager that owns the company, and then return whatever those properties are. So just a little bit of a heads up that we're going to be using Cypher. When we do retrieval augmented generation, in our case, what we're looking at is using the knowledge graph as that external grounding piece, which is what we're looking at here. So how do we actually go about building the graph? So there's a number of different ways that we go through it. And we will walk you through a little bit of it here, and then I'm going to show you some things in the notebook itself. So obviously, we know the challenge with traditional RAG is that when we're using a vector store, we're really returning based just on similarity, but not necessarily on understanding or business logic. I always like to use the analogy of a vector database is kind of as if you took, let's just say I'm onboarding a new employee and I have an employee manual. If I took that manual and chunked it up and tore it into little pieces and put them on index cards, each of those little pieces has information. But if I say, show me the index cards that are similar to, I don't know, a time off policy, maybe there's an additional piece of metadata that's connected to it that it may not be. But what we really need to be able to do is we need to be able to take the information but connect it to other things, which is what we're really doing in this particular instance, right? And so that's what we're going to be working on today is how can we expand that vector database to add in additional structured data to that unstructured data. So in our example that we use in this workshop is we have PDF documents, and these are about companies and finances and different risks associated in that unstructured data. And what we're going to be doing is we're going to be using AI to extract those entities and relationships, ultimately setting up for how we put it into an agentic solution. Now, the idea is, and at the end, we're going to show you just a simple agent. But what we really want to focus on today, and I want everybody to get out of this, is you've got lots and lots of conversations in this yesterday and today around how we're building agents. And what I want you to have from this is how do we put together the optimal data to get the best possible output from our agents, which is mostly what we're going to be focusing on today. So in this case, what we're looking to do is we're looking to connect our unstructured and our structured data. So for example, we're familiar with this process here on the left. We have the document and we create a chunk from it. This is your traditional vector moment. But what we also want to do is we want to be able to have access to the structured data. In our case, we have some structured data around which company is connected with that document. And the first thing that we're going to do is everything you see in red is going to be structure that's extracted from the unstructured data. So within these SEC filings, they talk about products, they talk about stock types or transactions or risk factors. This light blue element you see is actually coming from, in our case, you know, it's a workshop, it's a toy example, a CSV that outlines which asset managers own these individual companies. And so what you have in the end is what we built out is we built out this combination of your unstructured data in this vector moment. We have structure extracted from the unstructured, and we have whatever your traditional data would be as far as that structure is concerned. So this is what we're working up to today. What is the data that we're going to be working with and what's used here? What we have is we're using Edgar SEC filings. As we can see here, the original challenge might be, how do we extract this structured insight from thousands of pages of text? In our case, you know, we're talking about these quarterly filings that get filed with the SEC, and that's what we're going to be working with. And what we do is we take those documents and they're chunked and the vectors are created. So just as we can see here, what we're going to do is we're going to match the document. In this system, when you run this in Graph Academy, this data is already loaded for you so that you can play with it. And clearly what we're seeing here is we've got this particular PDF was chunked into 99 chunks, 72 chunks. Everybody knows there's an art to the chunk, but really what we want to show you is right now, when we looked at that diagram of the document and the chunk, what we're looking at is give me back this path. So show me the document where those chunks are coming from. What that looks like is I can actually, let's say match, I'm going to de-document. I'm going to create this. I'm going to look at the, again, this new laptop. I'm going to look at the from document, right? And then I'm going to connect that document to a chunk, okay? All right, and then what I'm going to do is I'm going to return, let's just return star, and we're going to limit to, let's say 10, just so that we can get a look at what this looks like. And the reason I'm running it this way is what I want you to see is I want you to see the actual graph. So in this case, we've got this one particular document. We see that this document, these chunks, this particular chunk is from this document. And the other thing that we see is we see next chunk. So again, this is another way that we can, maybe you're building an agent where you want to bring back that vector chunk, but you want some context. So you want maybe the chunk before and after. In these cases, by having them set this way, it allows you to bring in that immediate bit, but also see how everything is set up within the graph itself. What we've done, and I'll show you the, I'll walk you through what's in the code as far as how we're extracting this in just a minute. But what we've done is we've then done the schema-driven extraction. So what we've done is in the GraphRAG notebook, we've said, okay, I want to look at the companies, I want to extract entities such as executive, product, financial metric, like we had seen on that earlier layout. Then I want to also create these metrics here. And what this ends up looking like, we've got our code spaces up here. When we are in the document, you're going to see the our financial documents. What you'll see is the PDF build. So in the PDF build, this is actually going to show you, this is actually the notebook that walks you through how we actually did that. So clearly we set up your .env file. One thing to note when you're using Graph Academy in this particular workshop, one of the things that you're going to see, hold on one second, close this. When you go to set up your, oh, why is this not working? What is my retriever? Uh-oh. What is happening? Uh-oh. Why is this not? Uh-oh. All right. Well, I'm not sure exactly why this isn't loading for me right now. Hopefully you guys can still, Raja, can you still see what we're showing right now? Hopefully. All right, I'm not really hearing anything, so I'm assuming that everything is okay. As I mentioned, one of the challenges that we're having right now, I don't don't know why this is not running to my next piece. All right, we've got our vectors. What is a retriever? Set up your development environment. All right, well, it looks like now this is actually running, which is good. In this particular course, when you go to setting up your development environment, one of the things that you're going to see is you can open in GitHub code spaces. So all of the documents associated with this will load. But the other thing that you'll see is you'll see the connection information. So you will have to bring your own open API key to run this, but what we see clearly is that we've got the information. So this database, this instance is going to get set up for you right away, and then it will be connected. It'll be connected separately. So let me move this out of the way. All righty. All right, hopefully we can still see everything. So just to understand what's happening inside the instance itself. So how we actually did this PDF loader is we went through and we want you're going to set up your .env. This information here is coming directly from Graph Academy. We're going to give this to you here. You can drop those in. You can also set it up with a .env file as you see fit. And what we've done is we've gone through and the first thing we did is we created these documents in chunks, right? We create these documents in chunks, and how do we actually do that, which is what we're looking at here. In my case, as we know, when we're trying to set up data that's helpful to our application, we always want to be mindful of the messiness of the data. I come from a long time data science background. I think I spent the first 5 to 7 years of my data science career mostly cleaning up data. And that's one of the interesting things to know about the new AI engineer moment is you really are, you're not just an SWE anymore. You're not just an engineer anymore. You really do have those data science and those data management skills. So what you'll see in this particular instance is we actually provide some additional information about how we want the names of the companies to be extracted. So the first thing that we do is we initialize the LLM. This is still set up with GPT 4.0 rather than 5. You can certainly adjust it to the model of your choice. But what we've asked it to do is we've asked it to go into the unstructured data and say, find that we have the company that's associated with that document and go in and extract all of these different elements. Now, I'm showing you one very particular structured way to go about it. We do have MCP servers available to help you do this. There's lots of ways to approach this. But in this case, what we're showing is we're showing you a very structured format. The reason I like the structured format is when we are in a non-deterministic space, any opportunity we have to get really clear and to bring some structure, I'm always going to opt for that. So one of the things that we set up, the way we set it up is we set up this Python dictionary where we say, okay, I'm looking for the label, the node label, that's the type of the node I'm looking for, which is an executive or a product or a financial metric. In this case, when I'm looking at the actual properties, I'm just looking at, I'm just looking at the name and inputting that as a string. You can, if you're looking for dates, you can set those in to return as date times. This is where you really want to get very clear about what is it in this unstructured data that's going to be useful to me, and how do I want that information to be put into Neo4j so I can access it. The next thing that we see is we see the relationship. So in this case, we're saying, I want to look at the relationships, has metric, faces risk, etc. And this is what we have here, say risk factor company, the relationship between them is called faces risk. As I mentioned, I put in an additional prompt template because I wanted to be very clear that I need the company names that are extracted to match what's in my structured data. And this is something where you always want to be thinking when you're looking to take that unstructured data and make it available in a GraphRAG application. You always want to be thinking of what do I have in my structured data stores that can be found in this unstructured data, and how do I make sure that that jump match is going to tie? In Neo4j, we have plenty of algorithms around entity resolution and different pieces like that. But in this case, I just wanted to show you a way that we bring in this prompt to run that. So the next thing that we do, and this is really the key here that I want to really highlight, is we're using the Neo4j GraphRAG package, and we're using something called Simple KG Pipeline. And in this instance, what we've done is we take the driver, which is connecting to our instance. We have the LLM that we set. As always, you want to make sure that what your embedding model is going to tie to how you're querying. But what we see here is then we're passing those dictionaries of the entities and the relationships. I also passed in the prompt template, and then there's something called enforce schema equals strict. And that means if you don't sort of rein in the LLM, it's going to find all different kinds of entities, all different kinds of relationships. And in this case, you want to really tie in and get really clear and clean on what that is. So when you run this, we ran this over the data set. And what we do is we run this pipeline. We ran it on all these PDFs. And then at the end, we create this vector index. And where you see this is you see this, as I mentioned, in our building of the graph. Let me take you back to here. This is everything that was done in this element, and this is what got us to this moment here. This is what got us to the ability to say we have all of these chunks. So what we then want to do is we want to say, okay, well, you ran all of this data here. When you've extracted these elements, how can I take a look at those? So here's one way that we can look at it. So once we ran this, we came out with 820 risk factors, 470 financial metrics, and this is showing us all of those entities that were extracted. A little piece about how we dropped in our structured data. So in addition, what you'll see in our second notebook, and I can share this with you, one moment. In the second notebook, the second notebook here, the loading the structured data, we show you a visual. There isn't actually any code in this particular notebook. It's really just the walkthrough of when you have your own data and you want to load it in, how could you go about that? So it encourages you to go to console.neo4j.io. One thing to know about Neo4j is we do have a free tier instance. We also have a community edition where if you want to download something locally, we have a strong open source soul at Neo4j in our origins. So we really want to make it accessible to you. So when you go to console, the Neo4j Aura console, which is our instances, we have a really clear walkthrough of how you actually will load in that data. One of the things to note is we've got these different asset managers in the companies, and we show you how to actually map out, and it's very, very detailed in case you want to see what these look like. We have all the walkthroughs of how do you add in a node, how do you add in a label. We do have a lot of, we do have many connectors. As you see here, we've got lots of ways that you can connect to your data. And the key is you ultimately want to be able to tie your unstructured and your structured data together. So there is a walkthrough in here in the financial documents PDF build about how you actually get to that moment. So the data that's in there and what we walk through in that notebook is what we see here. We have the name of the manager, the company name, the ticker of what they own, and what those values and those shares are. So as we mentioned, we've got this walkthrough of how you can do, say, a GUI load. We have many other ways that you can do it as well, and we talk you through that there. The interesting thing for me is once we actually get all of that loaded in, we now see that we've got what was extracted from the unstructured data, right? Those risk factors, financial metrics. We have the chunks where those PDFs were added in. And then the other thing now is we've got this asset manager. Now, in our case, we only have 15 asset managers. We only have a handful of companies. I think we have 8 or 10 companies range of documents. But one of the things that we note is that now you can actually take a look at a whole company. So what does that look like? So to dive in a little bit to the Cypher query. So here we're saying we've loaded these documents from Apple. And what we want to say is we want to show, we add what we call optional match. An optional match just means if it's there, show it to me. But if it's not there, don't break the query. So bring me back Apple. Show me if there are asset managers that own them. Show me if there are chunks. And then here, what we're doing is we're just doing the aggregation, right? So give me the counts on these. And what we see is for Apple, we have 175 extracted entities. So those are the products, executives, risk factors that we had discussed. We see that of our asset managers, 15 different asset managers own a portion of Apple. And we have approximately 44 text chunks that are associated with Apple as well. And you may be saying, you know, how might this be of interest to me? And what I can show you is, let's actually also look at, let's just do, instead of doing this, I'm actually just going to do a return star. I'm going to limit it to 25. And I want to show you a little bit about what this ends up looking like in the graph. So in this graph, what we're seeing here is we've got Apple. We've got all of these different entities that were extracted or a risk factor. So in this case, it faces a risk of, this is probably adverse macroeconomic conditions. We can see that it faces a risk of political uncertainty. You know, so we have all these different types of risk that it might be facing. The other thing is we're also seeing an example of an asset manager that owns Apple, right? And then this, we're seeing like an example of one particular chunk. And we also note that this particular risk that it's faced, which is geographic some piece, was found in that chunk. So under the hood, each of these entities that we've extracted is tied to that chunk. That chunk is tied to the company. The company is tied to the asset manager. And you may be asking yourself, why do we need all of these connections? How does this actually help my agent? It's going to help your agent in a variety of ways. One of the things I'll talk you through is, let's actually go to the retrievers. So when we talk about retrievers, we're talking about the ways that we can query the database and use that information as context. So whether you're using it as context for your agent for a memory moment, whether you're using it as context for like an actual, you know, NLP verbal response or written return. There's lots of different ways that you're going to be using this data in your agents. But what I'm going to walk you through is I'm going to walk you through a couple of ways that we do this. So everybody's familiar, I imagine, with your vector retrievers and your vector search. In Neo4j, the way that this is stored is in the, so let me actually do this. I'm going to show you the chunk. We're going to match the chunk. And we are going to return C limit 1, because I want to show you what it actually looks like in the, here we go. So we have a node here that's the chunk, but what's actually in that element? So one of the things we see is we've got this chunk, the chunk has an ID, we've got our embedding, which we're used to, that vector. We have the text associated with it. And these are the important pieces. So when we think about doing a vector search, what we're doing here is you still have that vector search and vector index like you do in a vector DB, but now it's a part of the actual node. And this element that we saw before, where we have this chunk, now we can say from this particular chunk, let's say I do a search on, and I do some sort of a vector search on a query. Now what I'm able to do is I'm able to, from that particular chunk, go to the company, or go to the asset manager that owns the company, or go to an extraction. So when we do this initial vector retriever, all that we're doing is a basic vector search. So if I say, what are the risks that Apple faces? I create this vector retriever. Here, what I'm doing is I'm passing it the driver. So clearly we want to connect to the database. The vector index that we created was called chunk embeddings. using the same embedder that we use to embed within the model. And I want to actually return just the text from that. So this is what that retriever is built to bring back. So then when you run this, oh, I don't have them run here, but you'll be able to run these directly yourselves because everything's loaded in already. What you're going to get is you're going to get those results. And in that case, you're going to have like a very clear table of what's returned. Within the GraphRAG package, you can actually turn it back into natural language. And we can do that by doing GraphRAG, which says, okay, give me the LLM, run those vector retrievers, and then give me those answers, right? Where things get more interesting is when we're talking about the contextual cipher retriever. And this is where GraphRAG is really going to sing, because what we want to be able to do is we want to be able to go and traverse the graph itself. So what does that actually end up looking like? So we can take you to our retrievers. Let's go to working with retrievers. And this is where you can actually run the retrievers yourself, and you can run them in here. So for example, I'm creating a vector retriever. I am going to embed that, and then I want to get a response back. The interesting thing, like I said, about the GraphRAG is that you're not just looking at the vector. You're looking at the vector as it ties to the other elements of the graph itself, right? So if we look at how we actually built the graph, let's just say I want to, so let me do it this way. So let's just say in our case, we are looking at this contextual piece, right? So I want to, go to our advanced drag. I want to be able to traverse the graph. So let's just say I know that my agent is often going to be used to, it has a tool, and I want that tool to be able to give me back risk factors for a particular company. There are a number of ways you can do that. You can certainly do it by a vector search on the risk factors. But the challenge with that is if I do a vector search, one of the experiments we did with this data is we said, give me all of the risk factors faced by Apple. Now, the vector for Apple risk, remember, it's semantic, it's not structured. So it could go into those chunks, and oftentimes it would probably give you Apple. But what we noticed is when we increased the K, because usually in your retrievers, you're returning a certain number of chunks or a certain number of vectors. As we increased the K, one of the things we found is it started returning vectors from Microsoft documents, because maybe Apple was mentioned, or something similar to Apple or similar to iPhone, or something that was semantically similar was coming in. And so what we know to be true is that sometimes the vector itself isn't going to give us what the structured element that we're looking for. Because in this case, I want to know what are the risk factors that Apple faces is my query, right? What are the top risk factors that Apple faces? You can see in my comments here, it's like detailed search with context, or why this is a bad query. The reason this is a bad query is because, as I said, as we increase the K, as we increase the number of elements we're returning, we end up not getting Apple at all. And so what we need to do is we need to refine how we're looking at it. Now, in our case, we happen to have extracted all those risk factors. When we ran it initially, we didn't. We tried running it, and then we said, oh, let's go in and extract the risk factors when we build the graph. So now if I want the risk factors from Apple, it becomes a straight match query. So match company where name is Apple and return all of the has risk. So it's really just this element here, company has risk factor, that then gets returned, and it's really straightforward and it's lovely. But there are times when we want to have a different element, a different type of traversal. So this is one of my favorite examples, especially in this data set, where we look at what is actually being returned and why do we need graph. You know, sometimes people will say to me, well, Allison, if you're just running vector search, I can use a vector store. And I'm like, yeah, if all you want is just the vectors, you can absolutely use a vector store. And then somebody else says, well, if I'm really just looking for something really structured, say those Apple has risk or asset manager owns, I can just use SQL for that. And I'm like, you're absolutely right. You can create a SQL tool, you can create a vector tool. But the question becomes, what happens when we need to traverse across the two, right? What happens when we get to that moment? So in this particular case, a prime example of this is this query here. Which asset managers are most affected by cryptocurrency policies? I can definitely look up cryptocurrency risk as a vector search, right? I could absolutely go into those chunks and do a vector search and bring back cryptocurrency, right? No problem. I can absolutely find out which companies are owned by particular asset managers, right? Like anything on this side, we could do a SQL query. Anything on this bit here, we could definitely do a vector. But the question was, which asset managers are most affected by a cryptocurrency issue? And in this case, the way that it works is we say, okay, I have a query that's based in unstructured data and is based in the vector, right? So what I want to do is I want to go through the vector search and give me all the chunks or the K chunks that are related to this topic, semantically similar. Then what I want to do is I want to find out which document it's from, which company published that document, and then which asset managers own that company. And this is where building out specific tools can be really helpful. Could you have something that's really dynamic where you say, okay, here's the schema, be super dynamic, create the query based on what someone's asking? Absolutely. You could do it completely dynamically. But if you know that this is a structure that's going to come up a lot or something that's going to be pretty impactful, if I'm building this agent to give me information about investing in asset managers based on what we've seen in these unstructured pieces, then this is a moment where I might want to create a tool. The way that we do that is with this retriever right here. And this is the piece. So if we look right here and chunk to asset manager query, one of the things you notice in the cipher statement is it starts with node. And that means first it's running the vector search, and then it's finding those chunks. And then it says, okay, based on those chunks with node, now make this traversal. And in this case, we're saying go from the chunk to the document, to the company, to the asset manager. Return to me the name of the company, the asset manager name, so asset manager in shares. And you could also, if you wanted to also return, say, what is the value of what's owned? You could pull that property out as well if you wanted to do a certain kind of ranking. But the key here is how can we leverage these type of retrievers to build out a set of tools that's going to be helpful for our agent? The likelihood that you have an answer or a moment or a context that is a combination of some sort of structured data and unstructured data I've had a really hard time coming up with scenarios where that's not the case. I jokingly said to someone the other day, if you're working on these systems and you're not using Graph, you're probably building in some sort of technical debt. And this is why. There's a lot of talking. You'll see, other people from the company talking about these elements. We start talking about how do we manage memory? How do we manage context? There's a really great course that Andreas Kolliger, ABK from Neo4j just released with Andrew Ng on deeplearning.ai. And it's all about the agent. We have some other folks that are working on some really interesting memory pieces, so you can definitely check out that content. But the reality is that in order for the agent to act effectively, and to create the appropriate pathways and outcomes, the context or memory is key. The context is not flat. The context has some sort of relation in it. Some of my areas of interest really become about tracking the agent pathways, right? You see different types of observability tools. We look out for tool looping and things like that. The graph is really important. Clearly, we're showing how it's important as a tool and as a retriever, but it's really important as a structure around what you're building as well. So to get back to what we're talking about, structured and unstructured in GraphRAG, this really is the moment where I believe that the graph sings the most as a retriever and as a tool. We definitely have one other thing to note is we do have the vector cipher retriever example. And in this case, all that we do is we say we can actually pass different, well, this is the same piece here. Vector cipher retriever examples. Yeah, this is another example of something where it was what might another tool be. In this particular tool, what we're looking for is based on that node. So based on like in this query, I think we're looking at what are some shared risk factors. So if I wanted to know what are the risk factors shared by companies who are impacted by a lithium shortage. So it would go to the lithium shortage or whatever my query might be, and then it would go to that company, and then it does another interesting traversal. It says, go to that company, find all the risks that it faces, and then show me all the other companies that face that same risk, right? So this might be a tool where you're trying to look for clusters of companies, or maybe a cascading impact, or understanding if one thing happens and this company is affected, what are some of those other pieces? So we've got an example of what that return looks like as far as the actual graphic. And in this case, is what we're seeing is we see these are the different companies, and this is where these are the risks that they co-share, right? It's always really interesting to consider what is the optimal answer and what information do we need for that agent to make a decision, for that final output after that agentic traversal. Really, in any given moment, if you have had a moment where you said, oh, I wish my agent knew X, or I wish I could pass this along. Imagine if you were able to pass not just the context in maybe a written context, but imagine what's possible if you were able to pass this graph of interconnections as context to your agent. Maybe it's this information and the previous few tools. There's any number of ways that you can evolve what's in this graphic form, and you pass it through as a JSON, right? You can pass this very clearly through as a JSON, as we noticed when we were looking. Oh, wait, no, it's not there. When we look at what those outputs are, when we run the queries, you can have them come through in really consumable ways. But this is what I really want you to be thinking about. What is it that we can pass through that then becomes helpful? So in this particular workshop, what we do is we then go through. So we showed you a few of these different retrievers. This is a great retriever too, where we take the schema. So you actually get the schema from what you've built in the database. We pass that schema into text to cipher. And then from here, we can say, okay, what are the company names of companies owned by BlackRock? And then we'll actually create the cipher query for you. So then you can go ahead and actually execute it. Sometimes folks will use this inside of building out a node, or any number of different ways that you can create the text to cipher. But in the workshop, and what we show you is we show you a few different notebooks. The first one starts with a basic LangChain agent. And, it creates this reasoning and acting agent. right? And the first thing that we do is, again, you connect it to your instance. But really what we're looking to do is we create this first tool, which is get the graph database schema, right? So in our case, we're saying the context is equal graph.schema. And the graph really is, in our case, you'll notice that we're using pieces that are already built into LangChain and LangGraph in this particular element. So we've got the create React agent, and what we're doing is we're saying, okay, get me the schema of the graph, and that becomes the first tool. And then you can say summarize the schema of the graph, and then it's going to give that back to you. Then what we do in notebook number 2 is we take that first tool that we built, but now we're going to expand it and add in a new tool. So in this case, we're saying, let's add in this retrieval query tool where we want to get the name of the company from that vector. I mean, it could be any of the retrievals that we shared earlier where there's a traversal of some kind. But really what we want to show is we want to show you how do you start to build out these tools in this LangChain, LangGraph scenario. So in this case, we've got it really straightforward. We've got this match element, match the node, and we're showing the traversal. This can get more complex like we saw in those other retrievers. And now what we're going to do is we're going to say, okay, return this way, order by descending. And so this is what's going to be coming back from the retrieval query. We've got the vectors. So now what we're going to do is we're going to create a new tool called Retrieve Financial Documents. And in this tool, what we're saying is we're going to chunk the vector. We're going to do the similarity search, right? The K is 3. And now we're adding this piece. So give me back those vectors. Give me back those chunks. So this is going to be pretty straightforward here. And we're returning the context. So now we've started out with getting the model. And now we can also add in these new tools to our tool list, right? So we had get schema, and now we can actually retrieve the documents from the chunk. And then in the final one, we're looking at the text to cipher, which we talked a little bit about already. And the new tool that we're adding here is we're saying, okay, generate a cipher template to query the graph database. Only use the provided relationship types. We're giving it like some pretty clear direction, because one of the things that we know is that we've already built out how we pull in that schema, and now we're adding in the schema into whatever this cipher template is. So now we've got the cipher prompt. We're passing it the schema and the question, and then we're setting the template. And now we've actually created this new graph cipher QA chain, and we're adding in these elements. A thing to note here, Martin, who I adore, who's one of my coworkers, put this piece in, and he's like, yes, just be aware you are trusting the generation of cipher to an LLM. It may generate invalid cipher queries, so please be mindful. As we have all learned from public discourse, you do not want to give your LLM generated queries free reign over your production code. So just a friendly reminder as always. But ultimately what we get to is we now have this agent built out where it has the get schema tool, the retrieve documents tool, and the querying of the database tool. So when you run this application, you'll be able to leverage all of these tools. The key to all of this for us is that what we want you to understand is as I mentioned, the likelihood that what is best for your agent is some sort of connection and relation is very, very high. Our goal and my goal in this talk today is to get you to see what's possible, how we produce and connect structured and unstructured data, and then how we then make that available as an example tool within the set itself. As I mentioned, this particular workshop and the details where you can reproduce it on your own is available at Graph Academy. A thing to know when you go to Graph Academy is that this particular workshop it's publicly available if you have the URL, but you will not see it listed. So if you want to go through this, what I would say is if you have questions, feel free to reach out to me on LinkedIn. I am highly available and try to be as responsive within a day or two as I can be. But graphacademy.com/courses/workshop-GenAI. I don't know if somebody can drop that in the chat, but just know this is here and it's available to you. I am available, like I said, via LinkedIn. If you need anything, Feel free to join the community.neo4j.com. We have a Discord channel that is also very active. And I really encourage you, take a look at Andreas's course with Andrew Ng at Deep Learning and dive into how you can improve your agents, not just with structured and unstructured data, but what is possible when we add this connected context to the variety of elements along your tool set. Again, thank you all so much. I really appreciate you. I appreciate your understanding of my lack of a face for you today, but please reach out with any questions you have anytime. Raja, thank you so much for having me, and I wish everybody good luck on the rest of your journeys throughout the course today and the talks today and your agentic moments moving forward.
Okay. Thank you so much, Allison. It was great having you. Do you want to, so we have some questions in the chat. Do you want to handle them or?
Yeah, sure. Let me take a quick peek. Okay, there's the forum. Okay.
And also, I mean, so someone pointed out maybe since it's a new laptop, sometimes they have those sliders on your camera. Maybe
I tried the slider and then it ended up looking like, where is it? Let me turn my video back on. I tried the slider. And this is what happens when the slider is open. So for some reason, I'm still not here. I don't know.
Something is off then.
Yeah. Oh, thank you so much for putting in the source to the workshop. I really appreciate that. Where are my Q&A? Oh, so many Q&As. Let's see.
And I can help you filter them as well. I mean, maybe you can take a look and maybe I can also.
Okay, so I'm going to start at the bottom and move my way back up. So how is the risk factor determined by domain knowledge expert, or is this automated? The way that it works when you use the GraphRAG package is that when I set up that Python dictionary of the entities I'm looking for, that's the information I'm giving the LLM to go in and find those entities in the extraction. So the risk factors are determined by the LLM which has gone into the documents to find what it deems risk factors and create those entities from there. Do you get a certificate for the Graph Academy courses? You do get completion certificates for Graph Academy. We also you can get certifications. We have 2 certifications. One as you have a Neo4j certification, then there's also a Neo4j data science and analytics certification. So know about that. So if you don't have enough confidence in the LLM generated queries to run in a production environment, doesn't that nullify the whole point of LLM as a tool? I'm not saying that we don't have confidence, but just as a general caveat, we just always like to say, like, I don't want to be liable for, an LLM query, but honestly, most of the time they are very good. But, it's more about don't have the LLM, delete tables, things that we know already. From YouTube, Graph Vector 1 use case is to make our search efficient. Yes, so the vector is very helpful in making it efficient. You are using cosine similarity to get as close to that semantic origin as possible. So it definitely will increase the efficiency in getting to that moment for sure. Yeah, let's see. Using GraphRAG, I use only Neo4j during retrieval, or do I need a vector data store? No, you do not need a vector data store. The vector is that embedding, and that vector is one of the properties on the chunk node. So you do not need a separate vector data store. And let's see, this image could be dry. Yep, we talked a little bit about how some of it is you could go traditional or live. Yes, there are real life implementations of MCP. I would say go to Neo4j, look up our MCP protocols. Michael Hunger, who's our head of innovation, our VP of innovation, has done some really incredible work with our team there. Study materials for Agentic AI with examples there. I don't know if the Graph Academy agentic courses are out. I would say if you're looking for agents right now, I would go to that deep learning course. I would do that. That's the most recent release that we have, is with deep learning AI. Yes, not all companies share the same risks. Some are common. There is a slight distinction. Does the full course for Neo4j Gen AI explain basics like what is RAG? Yes, Mustafa. Excellent question. I kind of gave you the fire hose version of what's in the workshop today. So it certainly was quite a bit. I encourage you to go back, hit that link that's in the Q&A, dive into it a little bit and get, go slow and really understand what's going to be in that system for you for sure. I know we're over time. So if I don't know, Raja, if you want to just email those questions over, anything that is unfinished. If you have questions that we didn't get to today, again, either the Discord channel or the community at Neo4j is a great way, or find me on LinkedIn, Allison Cosette. I will answer any questions we didn't get to in the time that we have.
Okay. Thank you so much, Allison. This was very helpful.
You are most welcome. And I hope everybody enjoys the rest of their day with Data Science Dojo.
Thank you, Allison. So we are going to take a 5-minute break. And right after the break, we have Bilge Yücel from DeepSet. She's going to walk us through the next tutorial. We'll go for a 4-minute break, actually. It is 11:06. We'll be back at 11:10 a.m. Okay, it is almost 11:10 a.m. I am going to hand it over to Bilge Yücel. Did I pronounce the name correctly? Is it close?
Yes, exactly. It's Bilge, yeah.
Okay, sounds good. So, Bilge, thank you for being here. I will hand it over to you, and you can go ahead and get started.
Thank you so much. Thank you for having me. It's great to be here and running this workshop. And let me quickly actually start sharing my screen. I believe you can all see that, so let's go. All right. So hello, everyone. Welcome to this workshop. It's great to be here. I saw like people from different places like India, United States, Turkey. I'm also from Turkey. So it's nice to see like great people in the chat. So today we're going to talk about on how to give eyes to our AI. So basically like building vision-enabled agents with Haystack. First, a bit about me. My name is Bilge. I work as a developer relations engineer at DeepSet for over 3 years. I have a bachelor's degree in computer science and master's degree in artificial intelligence. And since then, I have been learning and teaching how to build with AI. I'm on Twitter and on LinkedIn. So if you like to connect there, if you have questions to me around like building with language models or with Haystack, feel free to like connect. I'm happy to answer all of your questions. And I would like to also take some time on DeepSet. So DeepSet was founded in 2018, and since then, so for 7 years, we are solving custom AI challenges of big enterprises like Airbus, Siemens, Bosch, NVIDIA. We have 2 main products. One of them is Haystack. It's an open source AI orchestration framework for Python developers. And we also have our DeepSet AI platform, which uses Haystack as a backbone, but it's for AI teams to build and deploy their applications quite fast. And here's today's agenda. First, I'd like to explain you a bit about like the agents, workflows, and vision language models. And then we're going to take a look at how we implement those concepts in Haystack. As the next step, I will take you through a Colab notebook. Colab is, I think, like a great way to share code in like workshops like this. And I will also like make a demo of something, but you will have every material that you need, so don't worry about that. And in the end, hopefully, we'll have some questions we'll have some time for questions. All right, so you can scan this code and fill in the form if you like to get access to all the links and material that I will be sharing in this workshop, but don't worry about it now. I will also put it on the screen at the end of the presentation. So I would like to also know like where you are on your AI agent journey, basically. So have you deployed an agent into production? Are you working with agents? Maybe you don't need them. Maybe you just started to learn. So it's interesting to like learn about this because like every time I go to conferences and I do talks, it's like we are still learning, we are still exploring, trying new methods, trying to find the best methods actually. And it's nice to be in this journey with everybody here. I'm also curious about where you are at. If you like to share it in the chat, I will also take my time to go through and read. All right, let's start with our first concept, agents, workflows, and vision language models. So if you think about AI agents, probably you'll find very like different explanations, very different definitions in different blog posts, in different tutorials. And here's my definition. An AI agent is an LLM-based system that autonomously pursues a goal by interacting with its environment using tools. So you'll see like 3 items underlined here: LLM-based system, interacting, and tools. So basically, agents has LLM as their brain, and they can interact with the environment. They can understand what's happening, and they can make changes. They can observe those changes through the tools. So like, again, like you'll see different definitions, but I think in the end, the definition, all of them like boil down to this 3 things. And there's also like in this AI world, there are different architectures, and agent is one of them. As we said, like agent is an autonomous system if you have a complex multi-step problems requiring diverse actions, or if you have a task involve multiple tools and resources like deep research agents, that is very popular recently. Agents are great architectures for you. So basically, if the goals are clear, so if you know where to go, but if you don't know exactly how to go there, then agent is perfect. Like go for an agent and implement your system with that architecture. But we also have AI workflows. So these are defined flows. And these are specifically useful if you have interactions that can follow predictable patterns like question answering, like RAG. And if your task can be decomposed into clear steps, like document indexing, for example. So if you have some sort of files, you want to like convert them into, if you have PDFs, maybe you want to do OCR, then you want to split that into smaller chunks. You create embeddings for each of these chunks, then you put that into your database. So you see like the steps are defined and I know which way to go. So instead of like using an agent for that, it makes sense for me to use a workflow or pipeline for this. And especially if you value stability, robustness, and efficiency over automation, then yes, the pipeline is the architecture for you. Agents can be a bit risky for your application. And with that being said, let's also take a look at what a vision language model is and how it is different from an LLM. So when we say LLM, it's a short form for large language models. We basically refer to this text-to-text model. So basically, we use it for any type of generative models that we input the text and we get an output as a text. And vision language models actually work in a similar way, but they can have text and image inputs in the same time. And as an output, it also produces a text. And these type of models are especially useful for visual QA. So if we have a visual information, visual data like images or PDFs, then we can use these models to do some sort of question answering over that data. And I'm not going to gatekeep here. Hugging Face has a great article explaining vision language models. And in that article, you can find ways to choose the right vision language model, technical details of how these language models, vision language models are trained, and find ways of fine-tuning your own vision language models. All right. Now let's talk about agents in Haystack and how we approach agentic flows in Haystack. So as I said, Haystack is an open source AI orchestration framework by DeepSet, and it's the backbone of the DeepSet AI platform. It's open source, as I said. You can find it on GitHub, the whole code base, and it actually has been trending on GitHub for the last couple of days. So if you haven't already, feel free to go ahead and give us a start to keep the momentum going. It provides the tools that Python developers need to build real-world agentic AI systems with visibility, control, and modularity. And all of these characteristics come through our building blocks, components, and pipelines. Components are the smaller unit. They are responsible of one thing, such as like creating embeddings, generating text, document classification, evaluation, basically you name the task. And by connecting components to each other, you form pipelines. And pipelines in Haystack are directed graphs, meaning that you can have branches and you can merge those branches and you can even have loops. This comes quite handy if you want to have some sort of retry mechanism or some sort of verification of your answer. So by connecting these components to each other, you form this whole pipeline architecture. But this is not the only type of building block that we provide to you. There are also agents in Haystack. So agent is a component that accepts a language model from any provider. It can be OpenAI, Anthropic, Google, or Hugging Face models. Maybe you run Ollama, any type of generative model. And it also accepts a system prompt alongside with with some tools. And tools in Haystack agents can be Python functions, external APIs, other Haystack components, and MCP servers. And basically, user request comes to the agent, and by using the brain, the generative model, and the tools that it has, it generates an answer. This agent generates an answer. All right, now let's, after like learning the theory and having the basics around like Haystack and the concepts, let's now talk about how we can give eyes to our AI, and we're gonna specifically talk about like images and PDFs here. So I will take you through a multimodal agent through a collab. So this agent will be able to process images and PDFs, and it will also have an access to a tool around weather information. For orchestration, we'll use Haystack, and as our model provider, we'll use OpenAI, but I'll also show you another way of using another provider. And with that, let's go and see our collab. Can you still see my screen? You should be able to see a collab now, but hopefully you do.
Yes, we do.
Okay. Amazing. So here, as I said, we're gonna use Haystack, and I have like every code here, every code piece that you need in this collab. But if you need more examples, you can check our cookbook around like introduction to multimodal text generation and our tutorial around creating vision and text RAG pipelines. Let me maybe zoom in a bit so that it's better. All right. So basically, first what we do, we install the required packages. Haystack AI is one of them, and we also have other packages for us to process PDFs. All right. Then we're gonna install the packages, install some of the images and PDFs that we're gonna need. Actually, I don't need to run them all. So let's wait for this cell to finish, but then like let's go through the outputs of these instead of running them, because it's gonna take a lot of bandwidth of the connection. All right, so now we have some information, some data that we can use. And if you are not familiar with Collab, all of these files are basically here, downloaded for you. All right. Then as a next step, I'm going to put my OpenAI API key, and I've already put it as a secret here and then enabled that secret for this Collab notebook. So if I just run this cell, it will pick it up from there. So I don't need to worry about like copy and pasting it every time. So the way of working with language models in Haystack is through a chat generator components. And we have chat generator components for different providers like OpenAI, Hugging Face, Amazon Bedrock, Anthropic, Google, Mistral, Ollama, VLLM. If you go to Haystack documentation, you'll get a full list of all model providers and inference engines. So here what I do is like, I import my OpenAI chat generator because this is the provider that I'm going to use. I'll define the model GPT-4o Mini, and then I run this component with this run method and provide my message. And first, I want my message to have this user role. So I use chat message.fromUser, and I pass a very basic message like what is the capital of Germany, and I get an answer of that the capital of Germany is Berlin. So this is just to test that, okay, API key is correct, I can use a chat generator and it works, it gives me a correct answer. All right, let's move on. So for us to be able to process data, so process visual data, we need to first convert them into a specific type in Haystack, and that type is image content. So for example, if I have an image like a capybara image, and maybe I can show it to you. No, maybe not. Okay, you'll see it eventually, so no worries. So I have a specific component for that, image file to image content component, that helps me convert any image to the image content type that I need. So what I do is like I initialize that component and I provide some parameters, then I give my image and it converts it into that specific type. And then that type is like image content is basically has this base64 string for that image. It has some MIME type, detail, and meta information for that. And if you take a look, this is the image that I have that I converted into the image content type. So what I do next is like, I want to pass this image to my language model that I initialize actually here and get some insights around this. So for example, what I say is like, what is the name of this animal? And I just pass this image content alongside this query, this question. And I again pass that in the exact form to my generator. One thing to like keep that in mind here is that the model that I'm using with my generator component should be a vision-enabled language model. So you need to check that with the provider. Not every large language model can work with images or PDFs, so visual data. But with the new wave of language models, almost all of them support this. So here, then, like after running this with my generator, I get that the animal in the image is a capybara. It's the largest rodent in the world, etc., etc. And it also says about like things about the bird. So it kind of also understands that it's a bird. That was the image, and let's now take a look at the PDFs. So I also need to, like, if I want to work with PDFs without doing OCR, so if I want to treat them as images as well, I can, again, use another component called PDF to image content and convert my PDF into image content structure so that I can also pass that information to my language model. So let's do that. So I initialize this PDF to image content converter.
Sorry to interject. So there has been a question about the link to the notebook.
Yeah, sure.
And I did a web search. I did find a few, but I'm not sure which exactly is this one.
This one is not published yet, so probably it's a similar one, but not the exact one. So. Okay. All right, let me put it in the chat. If I put it in the chat, hopefully it will be. All right.
We have it, yeah.
All right, amazing. So, all right, let's move on. So I have a PDF. It's about, let me maybe show it to you. Yeah, it's here. So it's this one. So it's an information sheet from a provider, basically like putting out all the tiers that they have and what's included in that sheet. And what I do next is that I process that PDF, I convert it into an image content, then I pass that information here alongside again with this query. This time I want to know which subscription should I go for if I have more than 2,000 keywords to be tracked. And I pass that to my generator, and in return I get that if you have more than 2,000 keywords to be tracked, you should consider the advanced plan, as it allows for tracking up to 5,000 keywords. So if I go back to that, I can verify that, because like track words, like if this one has a limit of 2,000, this one has like 5,000, so I need to go for the advanced package. All right, so basically now without doing OCR, I can read the PDF and I can ask my questions to that PDF and get reliable answers for that. And I can also use the same thing for slide decks. So what I did, I basically, if I go back here where I downloaded all my things, I basically use the presentation that I have, and yeah, it's in a PDF form, and it's a short one to make it easier. But I also uploaded it here, again, converted it into an image content. And I asked, like, based on the slide deck, what are the differences between agent and pipeline architectures? And in return, I get some great answers, because it puts in an exact way of how I describe an agent and how I describe a pipeline architecture, like that it emphasizes stability, robustness, efficiency, so it can understand what I'm talking about, like in the slide deck, and answer, again, questions. So you can also go ahead and try different PDFs. There's another one, survey.pdf, and for example, for this question, do the planned actions seem targeted at the weakest areas? The LLM needs to go through a couple of slides and like combine the information that it got from them and generate an answer. So you can go ahead and try your own slide decks. This is actually a very common use case of these vision-enabled language models. All right. So now let's make our system a bit smarter, because so far we haven't been using an agent at all. We were just like communicating with an LLM and sending an image, sending a query, and getting an answer. But we can go a much more than that. But in order to create an agent, remember I mentioned tool. So let's just first create a tool. So there are different ways of creating a tool for our agent in Haystack. And one of the most common ones is like defining a Python function with the name, of course, and with some more information around the accepted parameters and a description, basically a doc string of what this function does. And if I put this tool decorator on top, then this Python function will directly turn into a tool that my agent can use. Because now if I check the name, this tool has, like, it has the exact name of the Python function. If I check the description, it has this doc string. And if I check the parameters, then I see like it has the location, type string, and the location to get the weather for. And yeah, if we go through this Python function, what it does is it uses a client to get the current weather information in that location. So it accepts a location and it queries a client and gets description, temperature, humidity, precipitation, wind speed, wind direction as a result. And if you're familiar with function calling, you need to pass a name, a description, and parameter schema to your agent so that it knows when to call that tool and how to call that tool actually. But if you just have a detailedly defined Python function, we don't need to worry about. The Haystack takes care of all the parameter schema, name, and description generation. All right, now we have our get weather tool. Let's go ahead and create the agent. The agent component in Haystack, you can directly import it through among our components. It's a tool calling agent, so basically it's built in a React way. It started as a React, but under the hood, it uses function calling right now. What I can pass to my agent is a chat generator component. And if I want to go with the OpenAI chat generator, I can do so and pass that generator. But I can also use other chat generators in Haystack. And these chat generators are going to be the LLM, so the brain of the agent. Then I pass the list of tools that I want this agent to have access to. Right now, I only have one tool, so I'll just pass that one. And I can also provide a very detailed system prompt. For this case, I just said like you're a helpful agent, but if you are, for example, if you're working with especially multi-agentic systems, then it makes sense to like give your agent a specific role of like saying like you're a, I don't know, like a customer success agent that has access to those tools, etc. But this is a very minimal example, so we don't need to do that. Then as a next step to be able to use my agent, I will actually use a map of Valencia. So this is like a screenshot from Google Maps, and it's again in my file. So I can just convert that image into an image content, but this time using this from file path method of my image content. And if I say show, I can see the content of my image. So if we go ahead and try to just send a text query to our agent, we can do so. Here I try like, how are you today? And as a response, I got like, I'm just a program, so I don't have feelings, but I'm here and ready to help you. How can I assist you today? This was a text query. So if I use this agent in a way that I pass this query and this image, and I ask for it to do something. For example, I ask for what is the weather in the area of the map, and I pass this map image content that I have. My agent this time, it says like the weather in Valencia, Spain is currently sunny with a temperature of 30 degrees. So I hope that it checks, it goes through this like tool calling. So it basically goes to my Python tool, so to Python client, gets some current weather information, returns that to the agent, and as the last part, like the agent can generate the final response in this text format. This is my assumption, but there's a way to be sure of that, and it's called actually observability. So rather than like agent being a black box here, what I can do is like we have this print streaming chunk, a built-in function, a utility function that we have. I can pass this function as my streaming callback to my agent and see the details of all these tool calls, all the process happening inside the agent. So if I run the same query, but this time having the streaming callback function, now what I see is like, okay, now there has been a tool call to my get weather tool, and the arguments that I used were location Valencia, Spain. And my tool returned this result, basically like description is sunny, temperature 30, humidity 55, etc., etc. So everything that I defined in my function. And this time assistant, so the agent as the final answer generated this one. So now I have more insights into my agent. So for this specific example, it again creates a value, but imagine having, I don't know, like 5 different tools, I don't know, 10 different tool calls, and something went wrong. So you like to have an insight on what's happening inside the agent and what went wrong, in which tool it went wrong. And this very simple utility function can help you with that when you're in the development phase of your application. Of course, you can define your own streaming callback function and pass that instead of this print streaming chunk. I have given all these examples in OpenAI format, but of course you can use different models, as I said. For example, Gemini 2.5 Pro is also a vision-enabled language model, so it also supports images. It means that we can also change the model of this agent and use Gemini 2.5 Pro instead. And for that, I need to install Google Gen AI Haystack package, enter my Google API key, and initialize my Google Gen AI chat generator with the model that I want to use. And this time, instead of basically passing the OpenAI chat generator, I just need to pass this Google generator here to my agent. And if I again run the same query with the same image, with the same settings, I get a response here. All right, so before I go to the demo where I will be showing you how to deploy this agent, are there any questions maybe I can answer like right now? Let me see. I actually don't see the questions.
Bilge, are you looking under Q&A, or I can help you screen?
Yeah, now I found them.
Okay.
All right, let's see. Okay, I see a question like, is it possible to have a single agent enabled with multiple tools? I think, yes. You can actually use an agent as a tool to the other agent. So that gives you a very easy way of basically like creating this multi-agentic system. And another question, does Haystack have context and memory? It depends on what you mean with context and memory, to be honest. So like if you can send me a LinkedIn message, we can discuss, because there are different definitions on context and memory. If you ask like you can build RAG applications, you can save the chat history, but is it what you ask? A question, another one is why only Valencia is selected? Because that was the image that I put my agent, but I can also show other examples of that. Another one, in your workbook, which tool figured out the Valencia Spain part? I don't see that in the streaming. Okay, amazing. So maybe let me go through that again. So you see in the image, this is the image of Valencia. So when I pass this image to my agent here, by passing this map image and asking this, what is the weather in the area of map? So what happened here is like my agent first analyzed the image and understood the content of the image, and it understood that, okay, it's a map of Valencia, and the user is asking about the weather in Valencia because that is the image that is provided to the agent. So that's why if we go to this observability part, when I pass the image, it understands that it's Valencia, Spain. So it uses this get weather tool to get the weather information about Valencia. And to get that, it passes the location information to this get weather tool. And get weather tool uses the Python client to get current weather information of Valencia, returns that back to the agent, and then agent composes that information as a natural language here. I hope that answers the question. Will this handle the images and graphs within the PDF or any other document? Yes, actually, it's when you're doing OCR, if you have graphs in your PDF, you kind of lose the text. You lose the context because OCR is extracting the textual information in your PDF, but treating PDFs as images through the approach can help you handle the graphs in PDFs and images. All right, I see lots of questions coming up. Quickly going through. Haystack is open source, completely open source on GitHub, so you can basically do pip install Haystack AI and start using everything. And I will also sharing the link. So for example, for this one, all I needed to do is to do this pip install. All right, without running a lot of time, I see lots of questions coming, but I also want to show more. So this was like the first part of this multimodal agent, but there's also another, like, you can also take this to another level and deploy it actually to your server. And this is through Webhooks. Webhooks is an additional package to Haystack. It's a tool to deploy and serve Haystack pipelines and agents as REST APIs and MCP servers. So you can basically deploy your agent, deploy your pipeline, and use it as an MCP server and connect it to an MCP client like Cursor or Cloud, for example. It comes with you create the custom logic and expose your Haystack agent and pipeline as an HTTP endpoint. And it also creates OpenAI compatible chat completion endpoints, which gives you a very easy way of having OpenWebUI as your UI. So I want to now show you how you can deploy the same agents with Webhooks. So for that, I will go to my Visual Studio Code. So, all right. So we have, let me maybe show you this one first. So we have Haystack demos repository. We have lots of repositories with a lot of content. Haystack demos is where we keep like end-to-end demos. You can find like a browser agent here. You can find a demo on Chatbot website through Webhooks. And today we're gonna go over this multimodal agent demo. And I already cloned this repository to my VS Code. So let's go ahead and like check it there. So This is the same Haystack agent that we implemented in Google Colab, but now we take it to the Python script environment and we're gonna do more stuff on top of that. So what I did is like I cloned this repository. It's a very simple step. Then I installed the dependencies. So you need like Python 3.10 to run this demo. Then I configured some environment variables, OpenAI API key, but you can also use other model providers API key here based on your provider choose. And now I'm gonna start my HeyHooks server in just 2 commands, and let me make clear this. All right, first I'm gonna say HeyHooks run, and it will start the HeyHooks server for me. And now if I open another terminal and if I say like HeyHooks status here, I see that no pipeline is currently deployed, but I have a server running in this localhost, meaning that I can already send curl requests to this localhost and get some answers. But let's make it easy. So we actually have, like, if you go to that localhost and /docs, you'll also end up with this Swagger documentation, and you'll find the exact, like, the status endpoint here. You'll also see like all the endpoints that you already have here. All right, let's go back. So now what I want to do is like I want to deploy this agent, and for that, let me show you the code. So if you go to this multimodal agent folder and this vision enabled agent, there's only one Python script here. So no other code, only this one. And here it's quite easy. What I have is like I have a pipeline wrapper class. You don't need to memorize here at all. It's just like a copy paste code. But what I did is like, remember like this agent that I created with OpenAI chat generator. It has a system prompt, it has tools, get weather, and I also initialize this get weather tool here in my setup method. Then the second thing that I need is this run API. And this run API is my basically connector code piece to an HTTP endpoint. So what are the inputs of this HTTP endpoint that I want? And what am I going to do with that? So since my agent can process queries, so textual query and images through image path, this is what I did. So this function accepts a query, image path. Optionally, I don't have to provide it all the time. If there's an image path, I pass query and image together. If I only have the query, I just pass the query. And what I do is like I run my agent with this content part, so with the information that is provided, and I just return the last message of that agent. So if I now go and say like, HeyHooks pipelines, this is deploy files that and I want to give a name to that. So I'm going to say like vision enabled agent and tell HeyHooks where this code is. So it's in multimodal agent / vision enabled. Oh, this is not underscore. This is dash agent. Okay. Oh, it's supposed to be pipeline. Sorry. Yeah. So now I deploy this pipeline, meaning that now I can go back to this Swagger documentation, refresh, and here I have my endpoint. And here basically I can do anything. I can do the same thing. And what's the weather? Did I type it correctly? Weather like in the image. And here I pass multimodal agent / map.png because that is already here given, like I have this same image here. And if I run this in this documentation, so basically I'm sending a curl request to my endpoint. It takes a bit of time. But now I have the same information here. It figured out that it's Valencia and it made a tool call. It returned me the answer. So basically, if I just have a UI on top of that, I have an agent running. This is a multimodal agent. I can upload like any image, any PDF that I want, and I can get a response. But let me also show you how you can also connect this to OpenWeb UI. So let's go back to that code. And for that, the only thing that you need to do is to have this extra run chat completion async method in the pipeline wrapper again. Let me maybe zoom in here. Okay. And I just pass this my agent as my pipeline. I pass my messages, the messages that I want to pass, and I handle those messages through chat message from OpenAI dict format. So it's quite easy. After having this method, I can use OpenWeb UI for my agent. But for that, first, I need to run my Docker and let me see that. Yeah, I need to first like start OpenWeb UI locally through Docker. Let's wait a sec and see if it's up. Yeah, I'm waiting OpenWeb UI to be up. All right. So now when I go to, where is that? Let me go. Okay. Let me maybe go there. Yeah. If I go to localhost 3000, now I have my OpenWeb UI and I have my vision enabled agent here. So I can say like, how are you today? And it uses my agent, so it gives a similar answer that I use. But what I can do is like I can upload a file, this map, the same map, and what's the weather there right now? And here I even see like there was like a tool call, get weather with arguments location Valencia, and now I have a response. And here, if I toggle, I see like Valencia here as the tool calling argument, and I also see the response. And I can maybe see like, how is the weather in Berlin right now? These are just the queries for my agent. Like I enforce my agent to use the tool that I provided. And here it says like location Berlin. It figured like it understood that I want information around Berlin, obviously. And this time it used this get weather tool again with Berlin. And another thing that I can do here is like I can capture by basically having this Google Maps again and go back to my, what's the weather there? And like this time I provided like a map of Berlin. So I'm hoping that it will understand that it's Berlin, but it's not quite hard because Berlin, it's Berlin written here. Okay, so this time it did something funny. It noticed that it already has this information in the memory. So memory here, it's basically the chat history, and it already has this information in the chat. So it didn't go to the get weather tool again. It used the same information that it had in memory and returned that. All right, I don't have much time left, so I'm going back to my presentation for other steps. So now what you have seen is like you have learned how to create a multimodal agent with Haystack through the Collab notebook. Then you also learn how to deploy that agent with Hayhooks and how to have a UI for that agent through OpenWeb UI. And all that code was like a small piece of code that you had to write as like a pipeline wrapper. But you can go ahead and provide more tools to your system now. So you can connect to MCP servers. You can use maybe like a multimodal RAG pipeline, create like a multimodal RAG pipeline in Haystack and use that as a tool. And there are also like pre-built GitHub tools in Haystack documentation. You can find them. So you can use those tools, maybe like build some sort of GitHub agent. You can try open models, open weight models through Ollama, VLLM, Hugging Face. There are like Llama models out there. You can try to find the model that works best for you. But you should always think about like observability. And if you want to take this agent into production, you need to also think about guardrails. Like what happens if the image is something irrelevant? What if my user asks something irrelevant? What if I return some sensitive information to my users? So you need to always keep that in mind. And observability is like quite easy to implement with Haystack. It already has this built-in feature that I showed you within Google Colab. And there are like different resources in Haystack on how to build AI agents with Haystack. We have like a tutorial explaining how to build a tool calling agent, a tutorial around AI guardrails, how to do content moderation and safety with open language models, how to create multi-agent system with Haystack, about tracing, about human in the loop. And we have 2 agent examples that might be helpful for you in your GitHub tasks. They come quite handy when you're dealing with an open source project like Haystack. And just a month ago, I launched this Building AI Agents with Haystack course on DataCamp. So you can also go ahead and check that course to learn about AI agents. All right. Thank you so much for joining me for this workshop. As I said, like you can find me on social media, on Twitter, on LinkedIn, and we can connect there. And you can also have this QR code, scan this QR code if you want to get access to all the links, the demos that I made, the presentation, etc. Yeah, thank you so much.
Thank you, Bulgari. Do you have a few moments to take any questions here? I see some questions.
Yeah, sure. Yeah, I see lots of questions.
Yeah, I think there is a question around how to restrict prompt injection. So that may be an interesting question here. Do you have any guardrails?
Yeah, so we have some ways of preventing that. As the first step, they can check this AI guardrails, content moderation and safety cookbook. And if they have like more specific use case, like if they're looking for a more specific solution, you can also they can also join like Discord, our Discord server. I am quite active there. Our like engineers are quite active there, and we either provide answers or like we take that into our roadmap for other months, for other weeks.
Okay, and there is one more question about the generic documentation, right? So any documents which guide to develop, test, and deploy in production. So is there a unified place where they can look at your documentation?
Yeah, so basically in our documentation, maybe I can take you also there. Let's yeah. Okay, so like first you need to start with like get started introduction to Haystack. Then you learn about like the Haystack concepts here. You'll see like all document stores, and here are the components that you can use. And if you scroll a bit down, then you have here like tracing, logging. So basically like production related documentations and how to deploy, and information about Hayhooks, like all the details around Hayhooks. So every information that you need, you can find in our documentation. But again, as a reminder, you can go to our Discord server, Discord community, and ask your question there if you're looking for very specific answers. And I think our demos repository, we also have great examples, end-to-end examples here. So like this demos can be a good start for them as well.
Okay, thank you, Vilke. And perhaps we have maybe another minute or so. So one last question about what is the difference of Haystack pipeline comparing to LangGraph DAG? Looks very similar.
Yeah, it is quite similar, but I think one of the biggest differences is that we come with a long list of components. So you can choose from this building components that we have in Haystack. For example, if you want to take a look at generators, like everything is handled for you. You don't need to worry about how to like switch providers for that. But if you have like a very custom logic that you want to incorporate into your pipeline or your graph, you can create your custom component, and here you can find it here. It's quite easy. It's basically you just need to write a new Python class for that. And one other thing that I want to mention is like we have a breaking change policy. So basically we are quite careful with what we push into the stable version of Haystack, and we make sure that everything is working all the time. We run our tests even on our tutorials, so that might be like also one of the biggest differences.
Okay. I think we do have more questions, and as you as you pointed out, there is a Discord server and other resources.
Yeah.
Reach out.
Yeah, please go ahead and ask those questions there. I'm gonna be like there for another hour. So yeah, I would like to have a chat with everybody there.
And do you have the? I don't know if the link to the Discord servers was posted here, but maybe you can go ahead and.
So if you go to haystack.deepset.ai, here you'll find this join Discord link. I think that's quite easy, but I can also like copy here and maybe paste it in the chat.
Yeah, that would be actually very helpful.
Yeah, let me try to find it. And yeah. All right.
Okay. So I think this should be it. Thank you so much.
All right.
For,
Thank you. Thank you for having me. Have a
you so
great
much.
rest of your day, night, evening. See ya.
Yeah. Okay, so we are going to take a 9-minute break. When we come back, we will have a tutorial by Frank Boucher from Reka on building Agentic AI Research Assistants with Reka. So we will be back shortly. 8 minutes, actually. It's already 12:02. So we'll start right at 12:10 p.m. Okay, so time for our next tutorial with Reka AI, and Frank is here. Frank, it's all yours. Please go ahead and take over. I know you have been patiently waiting for some time. Okay.
Can you hear me?
Yes, I can hear you.
Okay, the camera was working 2 seconds ago, and now it
This is very
doesn't.
interesting, right? So this is
Again, it doesn't start being disabled, but oh, it's disabled by you.
disabled by us. Interesting. Maybe someone from the conference team, they can actually take a look.
There it is.
Hey,
Hello.
hey, welcome. So I will go off camera. I will be around, but let me know if you need anything. Yeah. But it's all yours.
Cool. So you can see my screen?
Yes, I can.
Wonderful. Thank you, everybody. Bonjour, hi, welcome, welcome. So like the next session is about building Agentic Research Assistant. So we'll be having fun showing how to build an app smarter than just like a regular text-generated app. I have plenty of stuff. So in the chat, Nishan is with me. He's also work at the Reka. In fact, he's way smarter than me. He's part of the tech team at Reka, so like part of the engineer, really doing the work, training the model and things like that. So if you have any questions as I'm going, don't be afraid to drop it in the chat, and Nishan can help. I will have a period at the end where I answer questions or like maybe review important topics that Nishan thought it would be interesting to review. But don't wait for the Q&A at the end. Post it in the chat, and Nishan will help you there. So I want to start with like a quick demo just to show you what we'll be working on today. After that, I have a few slides. Obviously, I need to do the due diligence. So we'll be talking about Reka and like what it is, the API and stuff like that. And then we'll go really in the code and look how we do the things. And don't be afraid. Don't try to like clip the URLs. I will share all the links, the docs, the code, everything at the end. I have URLs, everything is saved. So without further ado, let's have a look to our demo. So we'll do this, and then we'll switch to my restaurant. I can do bigger, voila. So nothing crazy fancy, if I would say. It's just like a restaurant finder. Very simple website. The goal was to focus on the tech, not on like what it can do. So it's to give you ideas and how to do that. So here we have a site. I already did the research because, as you can see, it can take a little while to run a query. So to save time, I know I can make 3 minutes of talking, but I was, let's try to move forward quickly. So I will do the research ahead. So did search a restaurant in my area. In fact, in my area, in Montreal area, because in my area, there's not a lot of restaurant. And as you can see, nowhere I ask about the location. So the app find that, pass it to the API, and like return formatted information. So it did found the top 3 restaurant, provide the names, the addresses, the phone number, the website, a score, and the price level expressed in number of dollar signs. So $1, $2, $3 So that's pretty good. It's useful because there's a format. And also what I really like is I have the reasoning. So particularity, I will go into detail later, of Reka's API is like it provide all the details about how did it end up with that specific result. So you could go see the assistant. Let me just zoom here. Hold on. Okay. So like, you will see like, okay, assistant, it did a call. So, okay, best ramen restaurant in Montreal in 2025. That's good. So, it's not like in the 80s or whatever. And then we could see like, okay, it did call a tool. So we could expand, look at the tool. It was a web search. So we'll see like it did navigate and go through all those websites, find information, then assistants try to cross-reference and continue and like do this. So the app is kind of like having an assistant doing web research for us. That's what the goal is. So yes, in this specific example is just finding a restaurant, but you could imagine things that it could do for you, because even doing this type of research will take a lot of time. Even if my wife pretend that she can do it in 2 minutes, I'm sure she can't. And like going through all those websites and reading it and finding all the information, kind of copy paste it somewhere else, it will obviously take hours. So it's very useful to do that, and we'll see how we build it in a few minutes. But before we do, I told you I need to talk a little bit more about Reka. So let's go back to the slides and we can continue. So Reka, who we are. So we are a model trainer with a particular focus on multimodal efficiency. So very trying to make the multimodal and very focusing on efficiency. And because we like open source, sometimes we do open different models or like share a lot in open source. Recently, we publish an open source benchmark for deep research and things like that. So like we do collaborate a lot in open source too. There's different APIs. Today, the focus will be on research, so the blue one. I will mention Vision because I think it's super cool, but we didn't have half a day. We only had 40 minutes. So I'm not demoing anything Vision, but it is very cool. And I will show you a place where you can play with that if you want to. We have an app that is available, a website that you could go there and have some fun with it. So it's already there to play with, and an API is coming up soon, or was released soon. Like no, Vision API is released. Yeah, so you could definitely have a look there. So Reka Research. So today I will be showing how to use it searching online web, but it could also search into private document. So it could go through, let's say you have like tons of resumes and you're looking to fill the position, and you could go and say, okay, you know what? I'm looking for a candidate with 3 years of Python experience and maybe knowledge about RavenDB database or something like that. So you could go specific and give me the top 3 candidate, and the AI the model will go look in all those documents and return with the top candidate. And again, you will have all the reasoning. So like why Alex was not taken when Sophia was taken, like the reason why and stuff like that. So you will have all the details of that. So I think it's pretty good. The model excel in synthesizing. That's really hard for me, that word to say. So information coming from multiple information and make it like, making currents connection between those. So really good at it. And like we are very performant. I will show you in a few slides dashboard benchmark that we compare our model to others. And you'll see like the performance is really great. The response are great. And also like we are OpenAI compatible. So if you are already using an OpenAI API, you could just switch the URL and the model name, and you could right away use Reka API if you want. So that's pretty good. So like, again, just going quickly through the feature, it's very lightweight. So like right now, the way when we work with the, sorry, I have like a little blank. Private file, voila, private file. We work with Google Drive. So right now it's coming soon to the API. And again, transparent, grounded, because you see why there's no fabulation. You see every answer they are coming from the data you are looking for, and you have all the explanation. And it's optimized end to end because we are training it from scratch and building it. So it's really great for that. I kept that diagram because I thought it was really cool. So hopefully you like the diagram like me, because it was a comparison between a traditional search where you have like, you ask a questions, find me ramen information, and then it will go search online and obviously find information because there's everything online, right? Find information and then like pick the one that I think it's the best based on that research and return the result. Maybe the page that it was on didn't include the phone number, so you won't have it, but you'll have the best restaurant of ramen, compared to like the multi-step search where it will go. And I'm like, here I said web because we'll be talking web, but obviously you could go also private file if you want, but it will be the same thing where it will do the research, get the information, and then ask itself, okay, do I have all the information? Oh no, I'm missing the phone number. So go back again, do other research, maybe other source of information to find the phone number of those restaurants, and then come back and loop like that as many times as it needs. Or limitation, we'll see that we can control that looping later, because obviously sometimes we focus more on the time it takes than the end result, like having all the details, like we need those, I don't care how long it takes. So depending where is the sweet spot, we can adjust that. And then we'll synthesize everything, because now multi-pass, multi-documents, it will synthesize everything and give us the answer with a structured output. And that's extremely important, because as human, when I go in a chat and I ask, hey, give me a 3 best ramen in Montreal or New York or whatever, I will have a blob of text. I understand that. You understand that. And maybe it's like a bullet point, kind of like, so dash, space, probably the name of the restaurant. And after that, maybe it's the score and the address, and it's like best pizza in town or whatever. I say ramen. So best ramen in town, something like that. The second is dash, the name of the restaurant again. This time is a comment. So like the format won't be the same, but I will understand what it means. But in a program, in a system, when you're trying to use that output somewhere, then it's more complicated because you need to parse it, sort it, and everything. So when the format is spit out in a very specific format, in a schema, following a schema, then it's better. You have all the information, it's respecting the type of that property you're asking for. So then you could use that, and as we saw in the website earlier, displaying in a column or save it in database for later, or do something without having to parse. So it's much faster, more efficient to do it after. Sometimes there's glitch. I wouldn't lie that when I was building that demo, the score, sometimes it was a double, sometimes it was an integer, and I had to, tweak it a little bit. It was a demo, so I think I end up putting a string just because to keep it simple, but it's much easier that way. So like the flow, if we remove all those diagram and arrows and stuff, so like you ask a question, there's a lot happening, it will be looping, searching, and that's when we can change the setting, the properties, and fine-tune that research to get a better response with all the explanation. So we'll be working in that square today. So here I was saying that the comparing to the benchmark, so simple QA, a popular benchmark that we can look at different model. And recently, Reka built his own benchmark and put it all out there, open source, so you could use it also to compare it. And we did score very well. So pretty proud. That's why I put that slide there. Visions is another API. Like I said, I won't be talking about, but I wanted to talk about it a little bit, mention it, sorry, because I think it's super cool. So what you could do with Vision is like Vision will look through tons of hours and hours and hours of like, let's say, for example, security footage. And you could say, hey, when the FedEx truck pass, and then it will go extract the exact timestamp and like part of the video where that comes from. Or maybe you want to know, like in a, you could do any kind of research. It could also look at in real-time feed to for accident or aggression detecting patterns that happen. So it's very useful to work on recording files, so a bunch of video files or a feed in real time. So really good for that. And if you want to know, I put the URL here. If you want to play with it, I will share again that link later at the end, but at app.reka.ai/vision, that's where you have all the information with vision. So now it's time for me to take a sip of water. I just finished a cold and my throat is still not being nice with me. Okay, so let's go back to the demo and we'll be digging into the code. No, let's go to the code. Let's go maximize that and we'll stop it. And we'll just change branch. Cool. So this demo, I did it. Currently, the version we'll be playing with today is in .NET. We have the same simple in TypeScript, if you prefer. We don't have this version in Python, though we have other demo in Python. But we try to do different demo in different languages. And today I thought it would be fun to use C#. Though I did not use any SDKs, so it will be kind of like pure HTTP call. So I thought that was good because in all languages, a HTTP call they look the same in all different languages. So I thought it would be interesting for that. So if we look at the code quickly, so it's a Blazor website. So Blazor is just the way we write the thing. So it's a mix of HTML and C# code. So this part is that little form that we fill. And then like I'm showing, this is my grid where I plug a list of restaurant. And then for each property, the name, the address, the phone number, the website, the score, the price, like I share that information. And after that, I have another kind of in a different tab. I'm doing the same with the reasoning step. It's a little bit more complex because of like all the possibilities possible. Like, you know, this different step, and sometimes it's a tool, sometimes it's an assistant and stuff like that. But same kind of thing. But today we'll be focusing on like the calling because this is just web thing. So like I said, Blazor, it's part of like C# code. And after that, you have, HTML code and C# code. So now if we go in I can make that bigger also. Maybe it will be better this way. That's a little bit big. I cannot see a line. Okay. So yeah, so when we click on that search without any surprise, it will be calling search. And what it does, it lock the button, it start stopwatch, because I was curious at some point to see like, this is kind of like a tool, like it's a playground, right? Where we experiment different things. So I did put more than expected, or like what would be like a professional app, if I would say, just because, you know, if you're trying to fine tune, sometimes it's nice to see like the call or see the saving the output. So I have like a little bit extra in there. So that's why I have the stopwatch thing here. And after that, this is where we call the service. Okay, get restaurant reference. And I'm cheating right now because in my area, on my little island, there's not a lot of restaurant. And doing so, like when I was trying to prepare for this session, I was like, well, there's not, except if I'm looking for pizza or like burger and I'm expecting to have McDonald's, I won't have a great result. So that's why I say, oh, you know what, like I will hard code Montreal here. But this app is just like trying to get running some JavaScript, extract the location, not the location, but the longitude coordinates of the browser from the browser, and then find a city close to that. And that's the city I sent. So it's working. I have the files there. We can try it later if you want, but just to prove that it's really working. But like I said, it was disappointing to see the result that I was having. So that's why I'm hard coding Montreal here. So let's go in this service. And again, as you saw earlier, doing a research can take 3 minutes. So I could have like make a change and then talk for 3 minutes while it's doing this. Sometimes it's shorter though, because we'll be optimizing, but sometimes it could take a long time. So what I did is I cache all those answers and I'm running it locally. So it will be much faster for us just to kind of like play around. But obviously we could just run it directly through the API, just like as I'm presenting, and we are tight in time. I thought it would be more pleasant to use that. So, and after that, we have our query, and we're preparing our body. So here we have our model. It's a classic API call, right? Open API call. I said it earlier. So we are following, we have the same format than an Open API OpenAI query. So like it's the same thing. So you have your query, you specify your model, you specify your role, your user, and stuff like that. And after that, I comment everything, because the last thing you want to see, it's me doing typos. Because when I present, there's always a bit of stress, and my fingers have their own main goals and make me look full. So that's why I comment instead of like writing. So that's what it do. So like we finish that. After that, sorry, I scroll way too fast here. After that, we're passing our API key. By the way, API key, we have a free tier, so you could have one today if you want. I want to show you before, like, I wrap up this this session. I want to show you where you can get your free API key, so you could try it and have fun. Or experiment in a different app. Maybe your app you're already having is using an OpenAI API, so you could get your key and change it. You just have to use your key here and change the model, and you have it. So there is it. There it is. So just like that, you send your request and you get your answer. And after that, I'm just extracting it, putting it, deserializing it to have it in like strong type, because C# is strong type. That was not necessary. I could have do like child and go with like the classic JSON query thing. But since I was in C#, I thought it would be great to have classes. If you are looking into the code, all the classes are in domain. So they are all there. All those classes are there. Well, the thing I want to show was, so here, that's the geolocation JSON that like we were having. So that's the name of the city I'm in. And I was very disappointed when I try it. So that's why I hard coded. The response sample, that's the full JSON that we get. That's where all those classes come from. So you get your status. Did you stop it? Did it fail? Whatever. And then like in the message, you have your content. So that's the JSON that interests us, the list of restaurant. And then after that, you have all the reasoning step. So you have all that information. So it's a big, obviously, response with a lot of information in there. If you don't want the reasoning, there's a way also to cut it. There's like it's customizable, obviously, if you want to do it. But when you want to learn and you're doing multi-step, it's very important to understand what's happening. So, and that's why today we are keeping it to show it. Okay. So that's the thing. That's the thing. Did I show everything? Can we start coding? I think I did show everything. Cool. So the first thing we want to do, because we are using the output of our API into a model, I think the best thing to do will be to add the format. So we can do this with the parameter here, response format, right? So this is very easy. And if we go that function, it's at the bottom of my page, it's here. So get format, you just create a JSON format. So depending on the language you're using, you could be just like, if you're already in JavaScript, you could just go and put your schema there. If you're in Python, I saw there was, I forgot the name of the class. There's tools that help you extracting an object, the class, and then spit it out in a JSON document. In .NET, you could just like use something like that. So here I'm just saying like, hey, I want a list of restaurant. It's a list of object, restaurant, like it's an array. And I want those properties. And I'm specifying here, as you can see, like price level. I want that to be expressed in $1 sign, $2 sign, whoops, and $3 sign. That's what I'm expecting. I could have, say, heart. The score here could have been, I could have specified, hey, I want minimal value to be between 1 and 5 or 1 and 100. It could be thumbs up, depending on like what you want. So you specify it in your JSON, and that's the model will do its best to fill it up. Maybe phone number. My daughter says nobody's calling anyone anyway these days. So maybe the phone number is not used. Maybe it's not displayed on the restaurant, the whole restaurant. Maybe it will return blank because it didn't found the information. So going back again up. So that's in our payload right now. So we did now had our response. So we could try to run that. So we'll run it. So now we are in Montreal, and we're just expecting a specific format. Without any format, I couldn't bind it to my grid because the grid is expecting a very specific format. So now I could just go, let's say, search for pizza. Voila. So I have 3 pizza, found all the information. See the score. It's not present. It's possible, but it didn't create anything. It didn't have it, didn't find enough information. So it just put nothing. Didn't have the information, but because it's an integer, when I did that, there was an integer. After now, if we look in the schema, it's a string, but when I did that, it's an integer. So that's why it's 0. There's no null. And then the price. And if we look in the reasoning, we have all the reasoning. So search for pizza near Montreal, 3 restaurant, matching the user requests. Oh, one thing I didn't say is it's looking for Montreal because we hard-coded the value. But if we go back into the code this way, if we go back to the code, let's stop it. Oh, sorry, under the floating zoom bar. One thing I didn't show was our query here is, okay, you are a restaurant recommender. The user asks for food in the specific mood. So we look for pizza. That's not a mood, but I guess it could be a mood. And provide the 3 restaurant matching this mood in near city. So right now, I'm injecting the location in my query because we'll change that later. So right now, that's what it is. I could also not have include that and let the user search at the top, but then like every time is like, hey, do that near me. So like, I think by default, we're expecting to say, hey, I'm looking for a pizza near where I am, not where I will be, but like that could be cool. So this, now we have a format. So that was great. Another thing that we can do is sometimes it could be very, very long when you do research. Like I said, it will search again. We saw that it didn't have all the information for the number, so we could specify the maximum of views. We could go 2, 3. I think by default it's 10. So like when you don't specify anything, it could take a lot of time because the model will really try hard and make up to 10 web search and the different tools. Like when you're looking at the list of the tool, it will do that multiple times. Okay. One thing also we could do, looking at the time, I see the time is flying. So let's say we also add location. So what you could do is pass the user location and then pass the city. And there's more you could do. You could pass there's the city, the time zone, there's the area in the country, I think. So there's multiple component, but in our case, if I say look for a restaurant in Canada, not sure I will get in time to my table if it's on the West Coast compared to Montreal, assuming I'm in Montreal. And now what I will do is I will change and use this new prompt. Well, I say, okay, the first part stay the same. So you are a restaurant recommender. Use the user ask for the food in this specific mood. Provide fine. Let's go. Provide 3 restaurants that match this food. Always response in adjacent that match the provided schema. But I'm not specifying anymore where, because that's passed, in the user location, right? So if we try to execute this, so now if we go here and let's go with sushi this time, trying to put some variety here in the menu. So if I search, so now we have different sushi restaurant, and we have the score. Do we have the price? So different price coming up in the reasoning. We'll see like it should have maximum. If we expand the tooling, we should have a maximum of 3 web search because that was also part of my parameter that I passed. Right. So 1 was there. So this is a tool, but it's an analyze. So we're still up to 1 and going there. It's again another analyze going tool. Oh, that's a web search. So we are up to 2 now. And as the last one is, and 3. So we have our 3 web search. So you could limit this. It's great because when time is important, you want to limit the number of web search. But if you don't care about the time, maybe it's a long running task or something like that. You say, you know what, like take your time, find everything. Then you could, turn it to the maximum. So that's cool. So we have this, we have the result. I said we didn't pass the location though. They are still all in Montreal. Oh, no provided source. Interesting. I didn't see that before. So look like, didn't find a lot of information on that restaurant. Interesting. No, it's good, but no phone number, no website, no. That's weird. Anyway, then if I was in real life, I would probably jump into reasoning, trying to understand like what's happening. Why did he keep it? Why it kept it in the list if like there's no information. But we are in a demo, so we'll just say interesting. Okay, let's go back to the code because we're not done yet. I'll stop that again. So that's great. say we are running online, doing some research. So maybe you think that some websites are more important than other. Maybe, let's say you're building an MCP server using that information. You could go and specify specific domain. So like the API calls will only do the research on that specific domain. In our case, a specific domain will be, let's say, TripAdvisor. So doing so, if I'm running this, it limits, so only the web search will only happen on TripAdvisor. I could put more if I want. So it's an array of strings. So I could put all the websites I want. So let's run that. If I look for, let's say, burger. So if we go, so again, found 3 burgers. We have all the information. Are they in Montreal? They are all in Montreal. And now if we go in the tooling, we should see a lot of TripAdvisor, TripAdvisor, TripAdvisor. So it'll be only TripAdvisors, right? Because I only allow research on that web search. So that's great because now, yes, you go online, you specify the amount of like time spent researching, you limit you format your answer so it could be usable in your application, and you pass the location so like your user doesn't have to do it, right? So now kind of like work perfectly. You could do that. Another thing, and like I can show it too, though, like you will have to take my word for it, is sometimes we don't, like, it's fine. Let's say I'm looking for hockey score or something like that, or I'm looking for some information, and you want the best restaurant, or like whatever. Say search online, go everywhere, but maybe you don't want to specify here. I just put Uber Heat because that was one of the results coming, so I kind of like filter it out. But you can say, you know what? I'm looking for the best news about AI, but you know what? I don't want to see any Reddit page because people there sometimes rant, and even if like the information could be interesting, funny, or whatever, I don't want to use that in my research. So you could like block some domain. And they are exclusive. So if you block a domain, it means it's everything except those blocked domain. And if you allow a domains or a list of domain, it's only on those. So it makes no sense to have two. Don't ask I know why. Trust me. I totally tried both at the same time. I was like, yeah, you know what? It makes no sense. But I was curious. And let's again look for burgers. And we'll see that. I'm not sure. Like, I forgot if the list is different. I forgot to check the name, but it should be a different website tooling. If I go TripAdvisor, oh, that's yeah. Okay, so yeah, TripAdvisor. I thought I had like a. That's the same result. That's the same result. I should do a search. I should go live and search without say, you know, everything except TripAdvisor, and it will take a few minutes. But you'll have to trust me. Or one thing you could do, seeing the time flash, I want to show you because promise I will do. Is before I jump? I think I did show you everything, right? If I go back to the code, let's close all those restaurants running. I have a lot of instance of my restaurant running. If I go back to the code and I stop it and I look at the code, did I uncomment everything? Yes, I did. So I'm using the location. We are playing. We didn't play this because honestly, that's when you feel it when you're doing real query in a real world. We say, okay, like what happened if I put it to 10? What happened when I put it to 1? The difference in terms of quality of information and the time it took. I want to show you how you could try it by yourself using the app, or the code will be available so you could run it also in TypeScript or in C#. Location, we passed it. So yeah, I passed everything there. Or one thing, if you want to play locally, I kept the save to file so you could see the response after the fact and look into the details of the information if you want to learn more. I did put that for you. So let's say I'm done with this part. I want to show you the app where you could play. So I say app, it's a website. So it's app.reka.ai. And here you have like all the APIs available. So you have vision, you have research. So research, that's what we were playing with. Let's make it a little bit bigger. And if you want to play with those parameters, not in code, but just like with the very graphical interface, you could do that. So you could do a multi-step web search. You could do also a private document search. So if you want to play, we did have some samples, so you could totally use that to search for different resume and stuff like that. So let's say you want some resume. So now you have plenty of resume. So you could go and look for people here and you will see all the output. Or we could go search online and we could totally add source. No, that's not what I want. I want this here. So I want to do a web search. I want to specify domain. So I could specify specific domain I don't want. So I could say TripAdvisor. I don't want to do any typo. Show me the code. Let's go here. Do I have it? Close by. Voila. HTTPS. I don't want it to allow. No allow. So I could save. Oh, do I have location here? So here I have the search depth. So I could go. So by default, I think it's 10. I could be wrong, but you could change it and say, you know what, like I want just one. Find 3. Ramen restaurant in English. Restaurant. Told you I was the king of typos, right? In Montreal with only one E usually. Voila. So now I could run this. And just like before, it will do the search. Behind the scene, this was happening. In our app, what we do is we show, oh, why did it? Oh, maybe it found, but it won't search for it. It's not supposed to be using TripAdvisor. We see like different URL here, and I could go search, like have a look at everything he did. Look at. So it's analyzing, and it will find a restaurant. You could play with that. It's pretty cool. I'm gonna make sure I have time for a question. So let's run it. It can take a few minutes anyway. So we'll let it search and we'll finish the session. So let's just finish this. So what's next? What's next? That's a question I have for you, because now that you know that you could search online or in private file, what would you do with it? Like what feature is missing? Imagine searching in tons of files, like I said, like in resume CVs for finding your next candidate, filtering a little bit, helping you finding the good candidate, because like when you have like 1,000 CVs, it's really hard to read everything. So you could use that to help you sort and pick up like a subset of a good candidate. Maybe you want to sort different website with different document. So you could do that. So here, all the reference. So the first link is app.reka.ai. That was just the website where we're currently doing a search for the ramen. You could do that. Vision API is there too. There's the chat there too, so you could use that. The second link is GitHub, where you will see, let's say later today or tomorrow, the link exists, they're simple, but the code I show you is not yet there. I just want to add some documentation, so if someone missed this session, it can still be able to know what to do to execute it. But the code will be there. And if you go at GitHub Reka AI and you look for API simple, there's TypeScript also available and Python that is available. And if you want to learn everything, you can learn about the APIs, go to the docs, so docs.reka.ai. And with that, I want to say a big thank you before I start answering questions and we look at the Raman result. Big thank you. I'm F. Boucheros on most social, so you can find me there. Usually DMs are open, so you can ping me and ask questions. And if you are interested to learn more about Reka, you could go at reka.ai. And with that, I can stop this. Look if we found the result, if we have a result, while we check for the, yeah, so we look like we have a result. So 3 Ramen Restaurant in Montreal, the source, it didn't use, so it kept, sorry, I'm looking for my words here. I'm out of breath. It did respect that we didn't want to use TripAdvisor. Voila, that's the word I was looking for. So like, you know, it had plenty of code, like of suggestion to look at, but it didn't use TripAdvisor, just like we asked it. So very powerful tool. So did Nishan answer all the questions or still have some?
Frank, I noticed that a few people have been asking for links and resources. I was wondering if
yes, let me bring that back to the. So those are the link. So like I said, the first link here, the app.reka.api, that's the link of the app where you could try. One thing I didn't show how you could, well, like if you go there, the first thing you could sign in, and if you sign in, you will be able to have your API key. Or if you go to docs.reka.ai, the last link here, you also have a link from there to get your API key. And like I said, it's free. You could use it right away. And the code will be available.
If you don't mind, maybe you can copy and paste this in the chat window, so that way.
So I don't, where is the
chat window? Maybe I can ask my team to actually put
it. I can paste it, and because right now I only see the internal chat. I put it there.
Oh, I see. Maybe if you can put it there, I mean, we'll grab it from there.
I put it there. I just did it now.
Okay. Okay, I got it.
I close many windows when I start because I don't want to be.
And then I have posted it for everyone. Okay.
Oh yeah, I should have picked. Sorry, should have picked everyone.
Yeah. So I mean, Zoom is not the best user experience. I think most of us would agree on that. So let's wait if we have any other questions. Otherwise, okay.
Can stop sharing.
Okay. Thank you so much, Frank and Nishan. It was great having you.
It was a pleasure. It was fun.
Likewise. Okay. Thank you. And we are going to take this time a 12-minute break, and we'll come back at 1:10 p.m. Pacific time. Okay, our next session is with Michael Irvin, and we are going to learn how to go beyond chatbots. Basically, we will be building event-driven agents with GitHub Webhooks. Michael, you can take over and go ahead and get started.
Fantastic. First off, I'm excited to be here. Thanks everyone for having me today, and hope everybody's having a great day so far. So with that, I will pull up my screen here and move a couple of Zoom windows around and whatnot. All right. So yeah, we're going to be talking about really going beyond the chatbot with event-driven agents. And I want to start off actually with a little disclaimer. Okay. And that's first off, this talk isn't going to be able to cover every aspect of creating production-ready agents. Okay. At the end of the day, we're all still learning together. We're all still figuring out what does it actually mean to have a production-ready agent, what sort of testing and QA and validation do these agents need to go through? How do we test these things, especially when they're non-deterministic, et cetera? So in many ways, I want to kind of frame this talk as hey, I'm actively learning and building stuff and trying out new things. And so this talk is basically, hey, here's things that I've learned recently and things that I've been thinking a lot about, but also things that Docker is thinking a lot about it as well too. We'll see a lot of the Docker AI tools and capabilities as we go throughout this as well too. But and again, feedback welcome and anticipated. I'll be watching the Zoom chat and the Q&A and all that kind of stuff as well too. So if you have questions along the way, feel free to ask. So what are the things that we're going to talk about today? Okay. First off, I'm going to help set some framing of what and why of event-driven agents. What am I thinking about? What do I mean when I say event-driven agents? And then we're just going to go through an example of one. Okay. And so, yes, this particular talk is talking about using GitHub and webhooks and analyzing PRs and whatnot. And I'll talk about why I'm thinking about that particular space when we get there. But we're actually going to build the agent together here. So you'll see me write some code. I'll set up the models, set up the tools, the MCP servers, et cetera. And again, we'll iterate on that. We'll build this together. And then I'm going to wrap it up with some lessons learned. So as I went through this journey and this experience, what are some of the lessons that I learned and what would I do differently if I were to start this particular application again? Okay. So with that, what and why of event-driven agents? Okay. Now, when we typically talk about Gen AI, we can basically break it down and define it like this. Okay. So Gen AI provides the ability for us to leverage models to create new content based on a set of input or prompts. Okay. And what this means is, yeah, I can use these models and I can give them new prompts and new inputs and new things that the model hasn't seen before. And based on the algorithms and the training of the model, it can take that new set of input and figure out, okay, based on this set of input, what do I generate? Okay. And that may be a chatbot response. It may be images. It may be code. It may be music. It could be a lot of different things. But basically, the models are basically doing predictive analysis. And I mean, it's a black box to most of us, but it's feeding off the prompts or inputs. Okay. Now, when we talk about agentic applications, the agentic applications take this a little bit step further. Okay. And agentic applications need three things. They use these models to both generate content and also figure out what steps are needed. But then they also have access to tools. And tools can provide a lot of different capabilities. Go look up information, go perform a function, a lot of different things. And we'll see some examples of that here in just a little bit. And then finally, there's the code that glues it all together. So how do we connect the models and the tools and and the code helps us do that. The code can help us have memory or do evaluations to determine, okay, are the flows working the way we expect it to, et cetera. Okay. But one of the things that's really interesting to me is when I talk to colleagues or friends or folks out in the industry or whatnot, they're like, hey, I made this agent, go run this command, and then open up your browser to localhost whatever, and there's a chat interface, and you kick off the agent with that chat interface. And I'm like, okay, that's cool, but why do I have to kick it off with a chat interface? Why do I have to have a chat bot to kick off some of these workflows? So for example, if I had one that said, hey, summarize my Jira issues and create a Notion page for me with my tasks for the day. I know it's just an arbitrary one. Why do I need a chatbot to do that? Why can't it just be an automated task that runs? Okay. And so again, when we start thinking about these agentic applications, what are different ways to kick them off or to trigger them or to launch them, whether that's time, whether that's events in our systems? What are other things that can be used to kick this off? Now, I've basically kind of coined that of going beyond the chatbot. Okay, again, what are ways that we can think beyond the chatbot? As I started looking around at various applications, I've actually noticed that there's been times in which I've seen Gen AI being used and didn't even realize that it was actually being used. And actually, one good example of this was actually fairly recently, and this came from Apple Intelligence. I opened up my phone and I saw that I had several group chat messages that I had missed. Okay, and I had missed a message or two, and this is just an example here, but I miss a couple messages and I see, okay, baseball game tomorrow from 6:45 to 8:15. Okay. And then there's several confirmations. Okay, little Johnny's excited and can't wait, and all that kind of stuff. And several confirmations. Well, what happened here was the app itself went and summarized all those messages that I missed and then gave me a summarization of that. And so I can basically quickly catch up with the messages just by scanning through this list, and I can know immediately, do I actually need to go and do something here? Okay. And again, this is an example of an AI and an agentic application. Sure, it's probably not doing full tool evaluation, et cetera, but it's using models to do something for me, and it's giving me immediate feedback and value out of this flow. As I was looking at this particular example, I was thinking, well, how easy is it to recreate something like that? And one of the things that I discovered as I was doing that is, well, models are fairly flexible. Okay. I know a lot of times we're chatting or we're actually putting in, again, chatbot messages into our interfaces and sending those, but models are, again, pretty flexible. I can actually give it JSON data and have it do something. In fact, I'm going to do just a little example of that here. I'm going to pull up a little app that I've built that helps just kind of visualize the messages in a stack go into an LLM. And I can give it this system prompt that basically just says, hey, you're a tool that's going to generate summaries for a collection of messages in a group chat. Okay. The goal is to help the reader of the summary know if they need to take immediate action or not. The details of each message and will be conveyed in JSON structure. It's going to provide the name, date, and contents. And here's some rules about what the summarization should look like. Okay. No more than 200 characters. Don't summarize each message individually, but the entire flow of the conversation, so on and so forth. Okay. Now, so what I can do then is I can say, well, hey, let me put basically another user message on the stack. That's the JSON data here. Okay. And looking at this, okay, I see one message. I need the FAQ for the website. Can you make it work? And then, okay, about 2 hours later, are you there? Any updates? And then finally, never mind, we got it. We used the Reddit post. Okay. So I'm going to send these messages to the model. In this case, it's a Gemma 3 model that's just running locally on my machine. And what's going to happen is, again, Gemma is going to process this system prompt, the JSON messages, and I get this response back, this summary. Okay. FAQ needed by end of day, Reddit post used for FAQ creation, issue resolved. Okay. And so my application can do all this behind the scenes. No chatbot is needed to make this flow work. Okay. And again, thinking about this, we can do a lot more with agentic applications once we start thinking about what are other ways that we can trigger these types of these flows. So for event-driven agents, basically defined as agentic applications that are triggered based on external events, not a chat message. Okay. And those external events can be webhooks. They can be system events. A file was created or edited. It can be based on time. So every morning at 9 o'clock, I want to go and run these various tasks that are going to set me up for success for the rest of the day. Okay. And those events then flow into an application to create prompts and then generate some sort of result. Okay. So that's the space we're working in here. Okay. Now let's look at an example of one. The GitHub PR Analyzer. Now, why am I thinking about this? Well, I guess it's been about 2 months ago now. At Docker, we had an internal hackathon in which the theme of the hackathon was simply create an agent that helps increase your productivity in the day. Like, okay, that's a pretty broad topic, but I could take that anywhere. And as I started looking around, one of the things that, again, thinking event-driven agents, one of the things that I really wanted to help make better was we have a lot of sample application repositories, okay? Very simple apps to help containerize or to teach various things, workshops, et cetera. We have lots of these. And there's an interesting thing that occurs. Every so often, it's maybe every 2 or 3 weeks, or we have a student that goes through one of these workshops, one of these training materials, and as they complete the work, they submit a PR afterwards, basically saying, hey, here's the work that I did. Okay, so here's the Docker file I made. Here's the website change that I made, et cetera. And while we're really excited that they submitted that PR to us, we can't really accept that PR because it's going to inhibit the ability for the next student to actually complete the workshop. And you can see actually even with this screenshot here, okay, there was a PR that was submitted October 24th, and okay, we're not always super responsive with all these repositories, which is something I can do better on. About November 6th, we actually responded to it. Okay, so a couple of weeks later, hey, thanks for submitting this PR. We're glad you're excited to be learning about Docker. Keep it up. Unfortunately, we're not going to accept this. Okay. So I've been thinking about this space of, is there a way that I can automate this? Can I use models to basically say, hey, a PR was created, and now analyze a PR, determine if it's basically the work that this particular workshop is asking the user to complete? And if so, can we automate creating a comment and closing the PR? Okay. So let's look at what this flow might look like. When a PR is open on GitHub, there's a webhook that gets triggered. Okay. I can register on the other end of that webhook a receiver for my application. Okay. And then that application can use a collection of different tools and agents. And I guess I should back up and say, one of my goals with this hackathon, when I was building this, was I want to do everything using agents. Okay. And I'll talk about some of the lessons I learned with that at the end. But again, the way that this is going to work is the webhook is going to get received, and then I'm going to delegate first off to a sub agent that's going to analyze the PR. Okay, maybe this agent needs to go get additional details. Okay, what files were changed? What were the details of those files? Does this look like it's actually enhancing the tutorial, or is this looking like it's the output of completing the tutorial? Okay. I want to be able to generate a comment. Okay, so let's personalize it a little bit, or maybe even respond to, hey, we're glad that you submitted a Docker file, and great job learning about how to create container images. But again, we don't want to accept this PR. Okay, so let's generate a comment that reflects a little bit of the types of things that they're working on, and then finally another agent that actually goes and executes things, that posts the comment and then close the PR. Now, a couple of these tools or a couple of these agents are going to need tools to be able to actually go and get additional details from GitHub, post the comment, close the PR, et cetera. Okay. Now, so this is kind of the architecture of this agentic application that we're going to build here. The flow, what it's going to end up looking like, there's just a slightly different representation of what we just saw. Again, the PR will be received. We're going to extract the details from the webhook. We'll analyze the PR. And then there's a decision that needs to be made. Do we actually close it or not? If the agent decides we're not going to close it, then we're just going to stop our flow here. Otherwise, we're going to generate a comment and actually post and close the PR. Okay. All right. So let's get to building here. We're going to start off with the comment generator, because this is the fairly simple one. We're just going to generate a comment. And the goal for this agent, again, generate a comment to post on the PR while closing. The model that we need for this can be a pretty simple one. It's just going to generate some text. Nothing too complicated. Most models can do that these days. The inputs, I need to give it the details of the PR, who is the author, who are we actually addressing in this comment, and then the output's going to be the generated comment. Okay, we don't need any tools, so the flow is fairly simple here. I just need, again, a model that I can use to actually create this comment and go from there. Now, one of the things that Docker has released in the last couple of months is a tool called the Docker Model Runner, which makes it very easy to run models, either locally on my machine or out in the cloud, et cetera. But one of the really cool things that the Docker Model Runner provides is the ability to basically treat these models very similar to my container images. So I have a CLI tool that's the CLI commands that lets me pull and run commands, et cetera. And then there's also Compose integration, where now I can actually define my models directly in my Compose file and then inject those into my services. Okay. And so this allows me to, now I can do a Docker Compose up, and it spins not just my containers, but also the models that are needed there. Okay. So let's get to writing. Okay. What we're going to do is I'm going to specify the model, again, using Docker Compose. We're going to write the agent code, and we're going to get this all spun up here. All right. So with that, I'm going to switch over to VS Code, and again, you can use any framework that you want to use. In this case, I'm going to be using the Mostra framework. It's a TypeScript or JavaScript framework, but there's no requirement that this has to work that way. Now, the first thing I'm going to do is I'm going to actually open up my Compose file, and I'm going to define the models that we're first going to start off with defining the model. Okay, so we're going to use the Gemma 3 model to generate the comment. Okay, again, it's a fairly small model. It works very quickly, and I can plug that in pretty easily. And then what I'm going to do is I'm going to update my code here to specify that I want the Gemma 3 model. Okay, the endpoint var field here, okay, is let me just write this out and then I'll explain it. Okay, what this is going to do is when Compose starts, it's going to define an environment variable, name this, that's going to be injected into the container so that when I connect to the value of this environment variable, it's going to connect to basically the OpenAI endpoint that's going to serve this model. Okay, now from here, I can run Docker Compose up, and then I will have my model. Okay, and then the application running. All right, so what I'm going to do, and actually I'm going to stop that for a second, and I'm going to run this locally. Let's define the comment creator agent. Okay, so make a file, comment creator, and I know I'm copy and pasting, but I'll explain what's going on here. So with the Mostra framework, what allows me to do is I can say I want to create a new agent, and what's the name of the agent? And then the instructions are basically what's the system prompt for this particular agent. And let me turn on word wrap so it shows the whole prompt here. Okay, so for this particular agent, I'm saying you're a bot that's being used to create a comment for a pull request in a repository, informing the user the PR is going to be closed. Here's some background, here's some instructions, here's some specific details. And at the end of the presentation, I'll share a QR code that links to this repo so you can read through it all and everything too. But again, I'm telling this agent, how should you run? Okay. So I'm going to save this and I'm going to register it with the Mostra framework. Okay. And one of the really cool things that Mostra does is switch over to my browser on localhost 4111. When I'm basically running this in development mode, it gives me a toolbox, a playground that I can interact with the agents directly. So again, I can still see that system prompt that I just defined. And now I can start to actually write messages. Okay, so let's actually test this out. Let me give it a message. I'm just going to copy in a message. Okay, so PR to generate a comment for that will be auto-closed. Okay, so I'm going to give it, say, hey, here's the author of the PR, the org, and the PR number. And again, what's going to happen here is this is going to generate a comment using the Gemma 3 model that's running locally on my machine. And I'll jump back to the code to show you how it's connecting to the OpenAI endpoint. But again, here's the comment that it generated for us. Okay, so going back to the code, we talked about the system prompt, but one of the things I didn't talk about was how we're actually connecting to the model. Okay, so one of the cool things about the Docker Model Runner is it exposes an OpenAI compatible API, which means any tool, in this case Mostra, but it will also work with LangGraph or any other tools that you might be using. I can basically just swap out the base URL to now point to the base URL of Docker Model Runner. And then as the tooling creates its request and sends it to the OpenAI model, in this case, it's actually not sending it to OpenAI, out on the cloud, but it's staying on my local machine. Okay. In this case, it's actually going to localhost to run. Okay. All right, making sure I got everything. Okay, yep. So we've got our app, we've got our agent. It's using local models. Great. Okay, now let's talk about our next agent, the PR analyzer. Now the PR analyzers needs to do a little bit more work. Okay, we want it to be able to look at the PR and detect, hey, is everything working right? And is this the type of PR that we want to auto close? Okay. And so in this case, the model needs to be a little bit of a smarter model. It needs to be one that can do some reasoning, that can maybe do some tool executions and say, hey, actually, I need some more details. Can you go fetch details about this PR? And then based on the response, determine whether the PR should be closed. So we're going to give it some inputs. The output is really going to be, do I recommend this thing being closed? Okay. And I'm going to give it a collection of tools to be able to go get more PR details, even get the files and the diffs for the files that are part of the PR. Now, the question is, where are these tools coming from? And with this being an AI conference, I think most people have probably heard of MCP by this point, but in case you haven't, MCP is a great way to package up the tools and connect them to my application. Okay. And Docker has created an MCP catalog, in which this MCP catalog is a collection of containerized MCP servers, so that I could basically just run an MCP server. I don't have to figure out, okay, this is a UVX MCP server, so I need Python, I need UVX installed. What versions of those things do I need? Are there other system dependencies I might need, et cetera? With them being containerized, you just say, just run it, okay? And it doesn't matter if it's UVX or NPX or a Golang or Java or whatever. That's the beauty of it being containerized, okay? And then the MCP gateway provides the ability to easily run these containerized MCP servers. What it provides is the ability to say, hey, I'm going to run this, use the API socket, so it's going to use the Docker socket and credentials and things that are needed there. And here's the servers to expose, and I only want to expose certain tools, and we'll see that here in just a second, okay? So actually, if I switch over to the MCP catalog, if I just search for GitHub, because that's what we need here, okay, I could see that there's an official GitHub MCP server that has, in this case, 93 tools available for me to use, okay? And I can see that there's tools related to pull requests down here. So, get pull request, get pull request diff, the files, et cetera. So there's a lot of tools that are available here. I probably don't want to use all of them because 93 tools will really slow down my work and take up a lot of context, okay? But this looks like a good MCP server for me to use, okay? So let's get back to our code. We're going to now specify the model. In this case, we're going to use Quinn, a Quinn 3 model for this PR analyzer. We're going to set up the MCP gateway, and then we're going to actually write our code here. Okay, so let's go back to VS Code. I'm going to go to the compose file, and in the compose file, first I'm going to define the Quinn model. And so we'll put that down here. And one of the things I can do with the models, I can specify not just the model, but hey, this particular model is going to need a little bit of additional context size because, again, it's going to be having to get additional details, and that's going to start to fill up our context window fairly quickly. I'm going to connect the model to my, oops, that was the wrong one. Okay, I'm going to connect the Quinn 3 model to my application. All right, great. I've got the model. Now let's connect the MCP server, right? Now, the MCP server, as I mentioned just a second ago, I can use an MCP gateway. The Docker MCP gateway, again, allows me to just kind of spin up these containerized MCP servers. I'm going to specify I want to use the GitHub official, and then I've specified only the tools that my application needs to actually use. In this case, I'm going to give it access to git commit, git pull request, the diff files, get the file contents, and then I've gone ahead and added the tools that we'll also need for the last agent as well to actually post the issue and update the pull request to close it. So from here, let's go ahead and I'm going to go ahead and do that. Yep. Okay. Okay. All right. So we've got our. Oops. Oh, I forgot one thing I needed to do. This GitHub official MCP server needs a credential. Okay. And I'm going to inject that credential. I have an environment variable file that has a GitHub personal access token. And so what that's going to do is it's going to read this secrets file, inject it into the into the MCP gateway, and then it will use that credential to actually communicate with GitHub. Okay. All right. So we've got that started. Hooray. And we should see now. If I do Docker PS, I see the MCP gateway. Hooray. All right. Now I just need to actually write my analyzer. Okay. PR analyzer. Okay. And again, I'm just going to paste this in here. So the system prompt here is saying, again, you're a bot that's going to analyze a pull request for a repository and determine if it can be auto-closed or not. And then again, provides descriptions. Now here's the instructions. And then here's good indicators on when you should reject this thing or when you shouldn't. Okay. So we notice that a lot of times our students that submit PRs, they completely miss the PR description. Okay. So if there's no description of saying what enhancement is this providing, that's a pretty good sign that this should be something that's auto-closed. If the updated files include changes that don't suggest improvement to the tutorial, for example. So again, lots of little things here that help guide the model to know, is this something that should be closed or not? The output that we want is a JSON object that contains, in this case, 2 fields. Okay. Recommended to close, true or false, and then a description on why did the model decide this thing should be closed. Okay. So again, we're telling the model this is what we want to have happen. We connect the model to our OpenAI endpoint. And then the last thing I need to do is actually give it access to the tools. Okay. And so we'll go ahead and do that. MCP gateway. And with the Master framework, I can just create an MCP client that will connect to a URL. In this case, it's going to connect to the URL exposed by the MCP gateway. So in this case, it's actually localhost 8811/SSE is where it's running from. Now, actually, one of the things I'll show real quick. I meant to do this a moment ago. Is for those of you that haven't played with the MCP inspector, I can actually use the inspector to inspect again the MCP gateway, and I can list out the tools. And again, I see just the list of tools that are there. And so actually, let's go ahead and ask it, say, all right, let's look at Docker 11 getting welcome to Docker. I think that's a valid PR number. Okay, there we go. And so again, this is validating that the MCP server, everything is working correctly. Again, the gateway is using my credentials. If you haven't used the inspector, it's a fantastic tool, again, to help visualize and see what's going on with your MCP servers, how they're configured, what tools are exposed, et cetera. But also MCP servers can do a lot of other things as well too. So I'm just focusing on the tools capabilities right now. So the last thing I was just going to do was register this with the Master framework. And now I can go back and let's go to our agents, our pull request analyzer. And, let's go ahead and make a pull request. I've got a little training repo here that I can just use. And let's just say I'm going to make a Docker file from Nginx, run echo hello world, and we'll just send this to through HTML page. Okay. Sure, that looks like a good commit message, and we're going to create a branch so then we can actually submit a PR for this. Okay, so let's submit a PR, and I'm going to have my agent now analyze this PR. Okay, so let's go in here and say PR to analyze to determine if it can be auto closed. Author, Mike 37, owner, repo, temp training demo, and then PR number, which I already forgot the number, 14. Okay. And so what's going to happen now is, again, we're going to use the local Docker model runner to run Quinn3, and it has access to all these tools that we see down here. And what we should see is here in just a second, once the model's loaded and it starts processing, okay, yep, I see the request to say, hey, the model needs additional details. Okay, it needs to know about the pull request. So we see the request to run this tool. We see the response that came back from it. The GitHub MCP servers are very, very chatty. And so it takes up a lot of context and sometimes takes a little while for the models to process. But in this case, I get a response that says, yep, we recommend it close. The PR title suggests adding a Docker file for an Nginx container with a hello world page, which aligns with typical student workshop exercises. So again, we're able to test, we're able to validate, cool, this thing actually works. All right, let's continue on. Finally, the last agent, the last step here is let's post the comment. Let's close the PR. Okay. This last one, again, is fairly simple. We just wanted to be able to actually execute tools. But again, since we want to execute tools, we need at least a model that's smart enough to execute tools. And so we'll continue to use our Quinn3 model. The inputs, we're going to give it the PR to close and the comment details. The output, was it successful or not? And then finally, the tools will need to be able to post a comment and update the PR status, okay, which we already added with the MCP gateway. So in this case, we're basically just going to write the code really quickly because it's much of the same process that we did just a moment ago. So I'll call this the PR executor, and I'll paste that in here. The instructions, again, the system prompt, you're a bot that's going to post a comment on pull request. The comment PR details will be provided to you. Here's the steps to complete. And then one of the things that I noticed as I was testing this is sometimes it would, post the comment multiple times. Okay, so I tell the model specifically, you're only to post the comment once, and then don't change any other details of the pull request. I saw a couple times it would do some various things like update the title or description, that kind of stuff. And so again, things that as you test the agents, you'll start to notice the types of behavior that it might do. And so then you can specify those in the prompts. All right, so from there, I'll save this. No, I don't care about the memory. Thank you, Copilot. And then let's go ahead and plug this in. Okay. And again, now I'll have the agent over here, and I can just say PR to close. Well, we'll skip this. We'll just do a full demo here in just a second. But again, it'll follow these instructions. It'll post the comment, close the issue, etc. Okay. Now that we have all the agent code, now how do we actually connect it to the webhook? Now, normally I would deploy this application to a production environment or something like that. But during development and during testing, especially since this was just a hackathon, I wanted to do something that was fairly easy to do and didn't require me to actually deploy anything. And there's a great service called sme.io, which is a webhook payload delivery service. And basically, you can just create a new channel, and then in the settings for the webhook, you basically just connect that channel here. And so what ends up happening is the webhook will go to that SME endpoint, and then in your code base, you can create a client that then basically just gets those messages and then can replay it within your own application. So you don't actually have to have a deployed environment somewhere just to be able to do testing and development. So again, really useful service here. So I use SME to the PR would go to SME, and then my application would then have a SME client and forward it on to the app itself. And so let's go ahead and plug that in. All right. Fortunately, I've got all the code here, so I'll just uncomment this. But what ends up happening is that the SME client will connect to this endpoint, and as the webhooks are received or are sent from GitHub, they go to this endpoint. The client will also receive it, and then we'll replay it locally to a local webhook endpoint. So I just have a small little express server here that's going to take the webhook, parse the details out of it. So get the PR number, the org, the repo, author, just other details. And then what it's going to do is say, hey, Master, I want to get a workflow, and I'll show you where this connects here in just a second. Run this workflow, okay? And give it, or first get the workflow, and then run the workflow with this input data. Okay, so process this PR, and then we'll see what happens. Okay, so let's go ahead and I'll save that, and then let me show the workflow real quick. Okay, boink. Then I just need to plug in. Yes. Okay. All right. So the way that the workflow, kind of going back to this slide here, we need the agents and the conditional branching and everything. That's where the workflow comes in. Okay. So what we'll see here is I've got a workflow. Here's all the starting schema. Okay. First off, we're going to use basically a step that's going to use the agent, that PR analyzer, to determine, can we close? And then based on that, we're going to branch off and say, hey, depending on the output, if it recommended we close, okay, if the recommendation to close is true, then run this next step, and then run the PR execute step. So again, the workflow allows us to do all this branching and conditional logic, connecting all these different agents together. All right. Let's go ahead and kick this off then. And so what we should see now is, let me clear the logs there. I've got the webhook set to anytime that a PR is created or reopened. So what I'm going to do is I'm going to close this and then reopen it, and we should see the webhook get triggered. So I'm going to click reopen, but before I do that, I'm going to switch to VS Code so we can see the log output here. So reopen. I thought I should have seen the, should see forwarding. Okay, maybe it just didn't pick up that code change. Okay, let me bounce, close the PR, reopen the PR. Okay, there we go. So PR webhook received, okay, for the close, and so it's ignoring it because it's a close. But then when I reopen it, I see another PR webhook show up. We can see it's kicking things off. Okay, we see the first agent that it's going to analyze it. That here's the details to analyze, and then we get the recommended close is true. And so we see that. We then should see the next one where it's going to then use our comment creator. So we see the comment creator go. It's going to generate a comment. We see the response from the comment going now. And then from there, what we should see is the final one where it's actually going to post a comment and close the pull request. And again, it's going to be delegating to the various tools. We see it actually went and fetched GitHub details about the PR. And so now we see pull request is successfully closed. And so actually, let's go back to our browser. Oh, there it is. So we see that the comment was just posted, and the PR was automatically closed for us. Okay. And I see a couple of comments here as well too. What's the best way to secure the webhook endpoints? Now, since this is just a demo here, I don't have the safety in here, but webhooks coming from GitHub can be signed with a secret, or there's a whole credential mechanism. But a lot of times also what you'll do is you can say, hey, I get this PR. coming through a webhook, a lot of times applications won't use the data directly from the webhook and say, okay, cool, let me go kick off this workflow. But to say, hey, I got a PR open for PR 14 in this case. Let me go get the details of PR 14, and then I'm going to use the results of that API call for the downstream things. And so that further helps protect you from various attacks and whatnot. And as far as there's another question here: safeguards should we put in place so that an event-driven agent doesn't become a rogue actor making unintended repo changes? And that's a great call out. Now, that's why you really want to craft your system prompts to basically say, here are the things that you can analyze. Here are the things to look for. Here are the things that you can and can't do. The executor, these are the specific things that you're going to do. So I'm giving it the specific instructions on what it should and shouldn't do. But even then, I'm also limiting what tools it has access to. So, this particular agent isn't going to have the ability to delete repositories or to create repositories or close issues or anything else. It can only do the things that I'm specifically giving it access to do. And so that kind of multi-tiered approach helps me have a much better and secured agentic environment here. Okay. Now, a couple of things that I want to share, some lessons learned. Okay. Because there's quite a few. All right. Now, obviously, there's still gaps in this application, and I see a couple questions of, how do you test? How do you deal with false positives, et cetera? Now, since this was a 24-hour hackathon project, I can only do so much in it. I didn't talk anything about testing, and there's some things that we can do with testing. Okay, I can use frameworks like test containers to actually spin up the models and basically do full integration tests and validate the things that are working. Okay, when it's going to call out to GitHub, maybe instead of talking to the real one, I'm going to mock those responses and kind of control a test environment. Okay, there's also other things that let's see. Let me pull up here. Testing your agents with evals. Again, this is just a capability of the Mostra framework, but a lot of other agentic frameworks have similar types of things where you can put basically evals or evaluators into the code base to say, hey, when this is running, I expect it to have this kind of tone, or it should be similar to this other content. You can do A/B testing with it, and there's a lot of different evaluators and ways to score things. So again, there's a lot of mechanisms that are available to help you test and validate your agentic applications. Obviously, just didn't have the time to go through all that here. The second thing, local models can do great things, but they still have limitations. So, again, I'm using Gemma 3, I'm using Quinn models, and I have a fairly, good laptop that I'm working with here. But am I going to be able to do full general purpose types of applications and a chatbot that can look up everything and give it 90 tools? No. So again, you really want to think about what are the specific use cases, narrowing down the tools that are available, and then playing with the different models. And that's one of the nice things with it being a compose file. I can just swap out the compose. Let me actually just pull it up here. Okay, I can swap out what model I'm using. Okay, maybe I want to try with a different variant of the Gemma 3 model. Maybe that's got fewer parameters or a different quantization, and see, maybe if I use a smaller model, does it go faster, and do I still get good results? Okay, so I can experiment fairly quickly. But again, local models, they're not the same as the large GPT models, the Sonnet models, et cetera. And so that's something to recognize. I think we're going to start seeing more fine tuning of models and more kind of, again, application use case specific models starting to be more commonly used. I think right now they're still very niche. As I was talking about earlier, MCP tool granularity. What I mean here is that sometimes the tools can be too granular. One of the problems that I ran into as I was building this and had to figure out the prompts is this executor quite often, it would post a comment, it would close, and then it would post the comment again. And what I found was man, again, the combination of local model and it being separate tool calls, that, okay, one tool call to post the comment, another one to close. And then sometimes it would get kind of mixed up of, have I already done this or not? Well, wouldn't it be nice if I just had a single tool that was just add, comment, and close, and it was all just one trip? Okay. So that's something to think about as you're building your own agentic applications of, hey, are there opportunities to kind of aggregate some tools so that instead of them being too granular, that you can have, one tool that performs multiple functions. Okay. Because what that ends up doing is now, instead of multiple trips and, more token usage and more cost if you're using remote models, more time and resource usage, et cetera, now it becomes one round trip to just add, comment, and close PR. And so it's faster, it's less usage or less tokens, less costs, et cetera. The other thought that I kept having here was that there are times in which I know that this step is going to be pretty deterministic. Okay, so this executor, for example, when I get here, I know that I'm going to post a comment, I'm going to close the PR. Do I really need an agent and a model to do that workflow? Okay, or could I just say, hey, GitHub API, here's the two API calls that I need to make, and that's just programmatic. Okay, and so as you're building your own agentic applications, there is value in choosing a framework that allows you to connect. Okay, maybe there's some agentic steps here. Okay, but then there's some other steps that are just flat out programmatic. Okay, post a comment, close a PR. It would be much faster than having to use a Quinn model and again do something that is very deterministic, and you know exactly how it's going to work, and it should work the same way every time. Okay, so to recap here, event-driven agents, they're definitely doable, and they're a great way to automate specific tasks. Again, you want to think about what are the very specific tasks. This case was a PR analyzer. Maybe there's others of, hey, I'm starting my day, and at 9 o'clock every morning, I want it to open up my Jira board and pull out my issues that are assigned to me and help me prioritize them, and then just give me a message. And again, now that's a cron-based, time-driven agentic flow. I don't want to have to open up a chatbot to kick that off. Okay. And so again, the challenge that I extended to you all is think beyond the chatbot. What are the other types of ways that you could build agentic applications to automate some little aspect of either your daily life or something that you're doing for a customer or for a user that's consuming and using part of your applications? Models and agentic applications have a lot of capability, but sometimes we have to think and break that mold in our head of using the chatbot. So with that, I've got a couple QR codes up here. There's the source code repo to this the application. There's a blog post that also walks through this as well too, and then there's the QR codes for the MCP gateway and Docker model runner as well too. So, and I say thank you. Thanks for tuning in. Thanks for watching. It's great to have I've seen a couple questions, and I'll get to maybe one or two of these before we've got a break, and otherwise I'll answer the rest of them just through the Q&A here as well.
Michael, you do have a few minutes. I see some interest there, so let's actually answer. We do have some time actually.
Yeah. Let's see. So let me see where I want to start here. Okay. So there's a question here. If the PR analyzer tool is a black box, how do you detect and deal with false positives? The tool may assume a PR can be closed when it's actually not. And that's something that I've thought about as well too. The last thing I want to have is somebody that's contributing to my application and or our repo, and hey, I'm trying to make this better, but you just think I'm a student, and like we don't want to give that experience. So there's a couple things that we can do there. First off, in our system prompt, wrong button there. We want to make sure that we're very explicit in what it's going to take to actually kind of cross the threshold to be auto closed. And so again, it takes a lot of crafting, the prompt engineering here, really getting into, again, what's it take to actually to close it. As far as, sometimes they may still get it wrong. Okay. So what can we do there? Well, for all of these repos, we're also getting email notifications or even Slack notifications in some cases for these issues. And so when new comments are posted, so for example, these are closed and comments are there, we can follow up on it and okay, let's double check, make sure that it wasn't a false positive there. So there's kind of secondary notifications to allow a human to be in a loop. And so that would be something else that you want to think about. Another aspect, you can start to use some of the evals that I was talking about earlier to help evaluate, maybe not necessarily the analyzer, but okay, the comment that we generated, does it have the right tone and things that we want there. So there's, again, ways to put a little bit of safety nets throughout the application there. All right. There was a question of how do you recommend handling secrets for agents running inside Docker when they need GitHub tokens or API keys? Yeah, and that's a great question. So going back here, we're using the secrets mechanism within Docker Compose. And so what this is going to do is basically load that as a secret. A secret gets loaded into a container as a tempfs file system. So it's basically a file that's only stored in memory. It's never actually on the disk. And then the gateway can read that file, and then it's going to inject it into the downstream containers. So that credential is never actually sitting in a file somewhere. And we're looking at other mechanisms. In fact, we're actually looking at the entire secrets engine of Docker and containers. And what's the next iteration of that look like? So stay tuned on that. All right. Let's see if we've got time for one more.
Michael, you have a few more minutes.
Okay.
Okay. I see a lot of questions here. So
okay.
As long as you have time, I think it should be okay.
What time do you want me to be absolutely done by?
Maybe 2:05. I mean, maybe
okay.
4 or 5 more minutes. Should be okay.
Yep. Sounds good. So there was a question, what's the name of the webhook service? So it was sme.io or SME. So again, that was the name of the service here. Again, I wouldn't use this for like a production environment but for testing and development, it's a great resource. What are some real world examples where Dockerized MCP agents provide clear benefits over running lightweight scripts or GitHub action workflows? Well, so you're kind of talking about a couple different things there. So a GitHub action workflow, so I guess the question here is, could I basically do this analysis in a workflow? Maybe not. The challenging part though is I need the model running somewhere, and I can't do all this in a workflow. And so I actually need a deployed application that can respond to these events and do something from there. So typically my GitHub action workflows are going to be around building, testing, validating, the app itself, where then external systems can then respond to these types of things here. All right, and there's a couple questions for links. Yeah, I'll drop the links in the chat right afterwards as well too. So that's a great idea. How can we handle continuing from errors from agentic workflows that were partially successful with one error, for example? Yeah, good question. So there's a couple different mechanisms that you can do here. So a lot of agentic applications will have retries built in. So maybe in a multi-step workflow, if step 1 passed, but step 2 had an error, having it trigger or, okay, let's go ahead and retry that again. That's kind of one of the advantages of some of these workflow systems where I know the input going into a particular step. And so if that step fails, if there's an error for some reason, okay, let's try that step again with the same input and see if we get the same error. If the error is persistent, then okay, yeah, then the application can send notifications or whatever it is that it might need to do from there. But again, having workflow systems that can retry, in a lot of cases, do resolve the situations there. And I think that's most of the questions. I'm scrolling back. Yep. I think that's most of the questions that I see here. So again, if you've got other questions, feel free to reach out to me. I've been getting lots of LinkedIn requests and everything as we've been going throughout it as well too. So feel free to reach out to me on LinkedIn if you've got more questions or think of something else, and I'll be happy to help you out. So thanks all, and hope you have a great rest of your conference.
Thank you so much, Michael. So are we getting closer to Cursor writing all the code and
Oh man.
All the pull requests being reviewed by tools like this, and then Cursor making adjustments, and then we just eat popcorn?
So my take is I think we're getting closer, but I think there's still a lot of steps to make. So I think for some very specific use cases, yes, but for the general use case, I think we're still a little ways off.
Yeah, it is fascinating how far we have come. Yeah. Okay.
Absolutely.
Thank you so much, Michael. This was very cool. And we are going to take a 5-minute break. We'll come back in 5 minutes.
All righty. Thanks all.
Thank you, Michael. All right, so we are going to move to our last tutorial of the day, which is building agentic workflows with FlowTorch. And we have Brijesh Kartha from FlowTorch who's going to present. And I believe we also have Hemant Joshi from FlowTorch along with Brijesh.
Hey
Welcome.
everyone. Hi
Hey,
Raja.
Brijesh. I was told that you're joining from India. That must be quite late for you. Brijesh,
You're
you
on
are
mute,
on
Brijesh.
mute.
I was on mute. Yeah, I was just saying that that's the way our industry is, so I'm used to this timings.
Okay, I see. Okay. And Hemant, you are also in India right now?
I'm based out of Austin, Texas.
You're based out of Austin, so not too late for you, right? So
No, not at all.
yeah, 4 p.m.
How about you, Raja? Where are you based out of?
Seattle. I'm
Okay.
based in Seattle, yeah.
Both
So,
well.
okay,
Can you
awesome. I will
rename
hand it over to
another?
both of you. Yeah, please go ahead.
Yeah, it's showing up. Okay, there you go. Simona is also joined. She's our VP of Strategic Alliance and Partnerships.
Awesome. Okay. I will hand it over to both of you, and it is all yours. I will be around. I will be off camera, but I will be here in case you need any help.
Right. So, Raja, just to kind of set things right, Brijesh would do the presentation, and I would be helping out answering any questions on chat or otherwise. Or Brijesh, if you need me on anything.
Sure. It looks like I need to just leave and come back for Zoom. Give me a second. Yes. Is my screen visible?
Yes, it is.
Okay. Hello, everybody. I'm Brijesh Karta. I head AI Developer Relations and Growth for FlowTorch.ai. And today I'm here to talk about building smarter AI. With me, as you notice, I have my CTO Hemant, and he'll be manning the chat channels. So if you have any questions whatsoever, please keep dropping it there, and he'll be giving you the answers. So I hope you're having a great time in the conference. I've been seeing some of the videos, and there's a lot of new information coming at such a speed. It's really invigorating, such conferences. And I'm sure all of you are really getting your hands dirty, making multiple AI solutions with all the stuff that you're learning. One of my pet topics in this area is about smarter AI. And I would like to take some time today speaking about it, specifically on how we can enable that with my tool, FlowTorch. So with smarter AI, the idea that I'm looking at is this point that AI has come a long way. Gen AI is just every month is doing something more fantastic. And it is incumbent on all of us who understand this to bring it into a system that will be useful to enterprises and organizations around the world. But we notice that that's not always happening. And partly we believe in FlowTorch that it's because we are not being very smart about the way we are doing AI. We are doing very powerful AI, but we are not doing very smart AI. And that's what we are trying to do with FlowTorch. So let's look at some of the pain points around this space, around this enterprise and AI. Now, generally speaking, this is the report that had come out from AWS. And looking at it just casually, it looks like it's a great thing. More than 44% of companies are going towards beyond the proof of concept, and they're going towards integration and transition, etc. But what I see is that there's still around 47% of companies who are nowhere close to even thinking about transitioning to production. And even the 21% who are transiting to production, what we have found in experience is that they are not entirely clear what is to be done. And there's a lot of vibe coding happening, but they don't know how to then convert that into a solution which can be secure, which can be compliant. So the whole problem statement for enterprises comes from an angle of cost management, because it's so easy for AI solutions to go out of whack when it comes to cost, that suddenly in two or three major requests, it can really blow the top of your cap. Similarly, they have a problem on compliance, security. They don't know what's happening. There so many different vibe coding is happening around the place, and they want to provide that flexibility to the developers. But how do they manage that? How do they monitor that? That becomes another concern for them. So keeping all of this in mind, we think we have a solution that can help alleviate many of these pain points. And that is the FlowTorch gateway that I'm going to talk to you about. So in the FlowTorch approach, what we have decided to do is that we are not creating anything completely new. We are going to use what is available. We are going to allow you to have your own assets, your own LLM applications, right? So today, if you have a typical LLM application, then it's about the business application calling all of these other items. We have the specific LLMs from the different providers in the cloud. We will put some guardrail add-ons either by utilizing something like a Bedrock guardrail, or sometimes we might even create our own methods, etc., to do some guardrailing activity. We'll have caching, we'll have routing, observability. I say we will have, but that also depends on whether we see that problem statement. Many people are still not using routing or caching as they should, because they're not aware of it. But the whole idea is we try to put all of this together, and that makes for a production level GenAI application, pulling all these different parts from different places and connecting it together for yourself. Now, what we are saying is that let's do the same thing. You bring your keys, you bring your assets, not a problem, but let us put it together for you. So what we have this concept of a FlowTorch model. So the FlowTorch model, it doesn't change anything, generally speaking, from what you see on the typical LLM application side of things. It's the same providers, it's the same routing, it's the same guardrails. But what we have done here is we have brought it into the model. So FlowTorch model acts like a LLM to an external party. Its integration point is just like an OpenAI framework for any LLM. So as far as the outside party is concerned, it's talking to an LLM. But the LLM internally is having the core LLM, which is a foundational LLM, or your own LLM, or your fine-tuned LLM. And you have the guardrails, and you have routing, and you have caching inbuilt into it. So now when you call the model, you invoke all of it. You don't need your developers to remember to bring in observability, to bring in model routing, to bring in caching. That is coming out of the model itself. And then we, on top of it all, we create the gateway, which is basically everything going through the GenAI pipeline is going through our gateway. And because it is going through our gateway, we are tracing it, we have knowledge of it, we have log information of it, and that then allows us to give insights back to you in terms of observability and governance. And it also allows us to give security from not just the guardrail and stuff like that, but also trying to look at things like policies at an agentic level that can be applicable to this entire model system. So I would like all of you to just keep this in mind, this idea in mind, while I walk through the next few slides to showcase why this means it is smarter for us. So let's start with LLMs. It's a GenAI pipeline. We have to start with LLMs. That's the core of the matter. So let's go for the traditional approach of LLMs, where I want to put guardrails. I mean, anybody who's ever put anything into production knows the guardrails. We need it. We absolutely need guardrails, right? So here I had my team just put together some guardrails using a Bedrock guardrail, right? And he put together a code to do that activity. And as you can see, there's a lot of setup and everything, but that's okay, that's code. But then you have to apply the guardrail, you have to decide how to extract it from the guardrail. And then you go and call the OpenAI call to get the prompt, get the answer, then put the answer into the guardrail, take it out, and then give it to the end result, right? So in principle, this is how it works. We can try to make it faster with orchestration, etc. We can try to make it simpler, but end of the day, it's a workflow which has components like a guardrail outside of the LLM. And because they're outside of the LLM, it means that somebody needs to ensure that they are being called. Somebody needs to ensure that they're being called in the right place and are being called regularly. It should not happen that somebody tries to put the solution into production and then suddenly decide, you know what, latency is a problem. I don't care. Just let me remove the guardrail. Now that is a problem for any organization. So that is the kind of thing that we would want them to care about. So how do we take care of that? Now, if you now remember that FlowTorch model we created, in that model, the guardrail goes inside that model. And because the guardrail goes inside that model, what ends up happening for me to call the same thing from FlowTorch is this code, where I'm calling the FlowTorch SDK, I'm giving you the required data points, and I'm creating the LLM. And if you notice, the LLM is just like any OpenAI framework LLM. You give the ID, the key, and the base URL. And then we give the message, and we get the response. Now, there is a guardrail in it. The FlowTorch router guarded model, which is the model I'm calling, happens to have a guardrail inside it. But that's the job of the GenAI architect to do. The GenAI architect has created it and put it into place, and now it's available for every developer in your organization to use. And because they use it, they don't need to care about how it is working. They just use it, and it works. So as a company, you can make it a policy that any and every model that you create needs to have some guardrails around, let's say, privacy, profanity, etc., and that is non-negotiable. So that anybody uses these tools, they use it. There, the guardrails come into place automatically. Now, these guardrails also come into place even if you're going to call it from a chat solution. So if you're writing Copilot and you want to call an LLM, instead of calling an LLM, you could call the FlowTorch model, which is in place calling an LLM, but now it's going through the guardrail. So even your code cannot do something which breaks the guardrail. So that's the way you can make it smarter, make it safer. Then we talk about caching. I was talking to you about caching in that model out there, right? And this caching is not the caching of the LLM when it decides to do, etc., or the server side. We are talking of caching at FlowTorch. Because we are seeing the pipeline go, and because the story is coming to the FlowTorch LLM, the FlowTorch model. The FlowTorch model decides that I have seen this question, and this is the response. When the next time a question comes, and if you have set up caching, which is an option you have, out of the box, you can either set up a simple caching or a semantic caching. If you have set it up, and you've set up some parameters which says so many questions will be cached, and these are the parameters for caching those questions. If those parameters have been set and they are hit, then those questions will be cached, will be responded to, and essentially you will never make the call to the LLM. You'll never go to the LLM. And because you'll not go to the LLM, what ends up happening is that cost saving, you're not sending tokens to and fro from the LLM, which automatically means that you're not paying for that. And second, you're saving time. So here, for example, this was one of our team members had put this together when they were working on it. This is over 30 days. And this Model 6 and Model 7 are both GPT-4 models. And in the requests which are going out, you can see Model 7, the requests are actually less than the Model 6 requests. But if you just have a look at the total token, that and even the latency, it's way different. And mainly because in Model 7, every single call goes to the underlying LLM. In Model 6, that's not the case. In Model 6, lots and lots of calls are answered by the cache, and that is saving all this token movement happening. Yeah. Now let's go and see how we can do this with the routing. Okay, so we know routing, and everyone does routing at any point of time when you're trying to create something which is slightly more complicated than just giving a chatbot. Somewhere or the other, routing comes into play. But typically what happens traditionally right now is we have to do the routing in our code. So either we do it smartly in our code, or we do routing using something like Route LLM, where we decide or some logic in the code. Or we go out and we say, okay, this is an orchestration framework we use, and we depend on that to do the routing for us. But essentially, again, the point is the routing is happening outside of the model. So traditionally, we have no routing in the model. We have to do it through code. And if there is any scenario like a coding assistant, which has a place for you to just attach an LLM model, you just cannot attach a workflow to it. So you cannot have a situation where you attach to it and you route it such that the token can go in round robin, right? So you attach to a LLM and say that I want to take this as a code assistant, and you're capping the token, right? But then right now you have to go and change it. You have to shift it around. That's would be required because the routing is outside the LLM. But the FlowTorch model is that the routing is available in the model. The FlowTorch model, being a wrapper around the LLM, allows for you to route inside itself. And we give right now in production, we are giving fallback routing. We are giving routing for round robin and weighted. And it is outright useful because without a fallback routing, it makes no sense to have anything in production. So in this case, for example, you might have a normal LLM as your main LLM, and then you might just have another LLM as a backup, just in case the main LLM is not reachable. So that's automatically then goes, it gives you 3 tries, and then it falls over to the fallback. Similarly, there could be round robin. You can go into a situation where you don't want to cap the token on any one provider. So you take an LLM, which is available from 2 or 3 different providers, and you put it into the FlowTorch model, all the 3 LLMs. Now, there are 3 LLMs in the FlowTorch model, and it's a round robin. So what we are basically saying is whatever is being hit at that point, they are going in a round robin, and no one provider is getting all the tokens, so we would not be capping it out. So in the future, towards the end of this week, we'll be having a time-based routing. So what time-based routing would do is that time-based routing would allow you to set schedules that at this point of time, this model is used, at this point of time, some other model is used. And you can think of it in potential use cases like in the busy time, you have a cheaper model, which is just answering chatbot kind of things. In a slightly non-busy time, off time, you take some of those questions and you can then start using it against a reasoning model because it's not so heavily used at that point of time. So there are many such options that you can use when such routings are available. And this is how it looks. All these 3 things I've been talking to you about, and the model and how the model looks, this is how it looks on the gateway. When I create a model, now in this case, I've created the routed guarded model. That model essentially gives this design canvas. And in this canvas, I have now added one guardrail. I have added 2 models, a GPT-4o Mini, and as a backup, I wanted to give a GPT-OSS 20B. I don't want to really use it, but as a backup. Now, the minute I do more than one model, I have a router available to me. I've set it up as a fallback, and that's it. In this case, I've not used any cache. Now, imagine this, that all of this activity, we are setting it up, but as far as all your code where you're using LLM, every single piece of code you've seen for the last 2 days, which is using LLM, that is going to use routed guarded model. Not GPT-4o Mini, not OpenAI GPT-OSS, routed guarded model. Which also means that tomorrow, if for some reason your company or your GenAI architect feels that GPT-4o Mini is not the thing, we need to go something else. We want to go for Gemini 2.5 Flash. It's as simple as putting it here. They'll come, they'll create a revision, they'll change the model, but none of the code calling routed guarded model needs to change. So that is one more advantage of this modularity that we have, that we can change the fundamental things because maybe security, maybe a leak has happened, maybe cost, right? We could do a lot of changes like that, and they're all contained at this point of the design and not at the point of where you're calling this solution. That will still keep working because it will be transparent to them. Now, when you do smarter, and I'm talking of smarter as being business-based and etc. So one of the things is absolutely speed, right? We need to do things fast. We need to do things yesterday because we are AI, right? So how do we do that using FlowTorch? So we want to build rapidly. Now, FlowTorch, you saw those models I'm talking about, right? So we don't have to now go in a situation where your entire company is asking for permission to do, can I go to Anthropic, can I go to Cohere, can I go to Grok? No. You can decide for a small set of people to say, okay, we're in a sandbox mode, let's get from everywhere, right? But control it. Control it in a way that the core group of GenAI architects sets it all up. sets up all those models, right? Sets up all those providers, decides which sandboxes require cheaper models and which of your scientists requires reasoning models. They set it all up, one-time activity, and now it's available as a sandbox to everybody to just play. So it's a quick POC creation for them. It's just like they just have an idea, they've got a flow, they put it into play, right? And when they put it into play, they will still have questions. Like the first question you always have is, which LLM should I use? They all look normal to me. And our answer to that is yes, they all look normal to you, but which LLM works best for your context? And to allow for that, we have fast experimentation available. We have experimentation right in FlowTorch. What it does is it creates parallel experiments. It just runs it against all the different variables you could put together. Maybe the hyperparameters could be the variables. Maybe the RAG itself may have different prompts coming in. Maybe different models are checked. You check all of those, get the traces out, give it to Ragas, get an output all done by the system. And you basically get a readout which says, for your RAG, for your context, for your agent, these are the best LLMs at this moment of time. And when you know that, if you know that this experiment is the good one, this experiment is the one which is giving me the best action, it's just a button press to deploy that as a RAG endpoint. Today, we can deploy it as a RAG endpoint. In the coming future, you'll be able to deploy it as an agentic flow. So that is also available in the tool. Write once, iterate often. Now, modularity is built up in the tool in the way models are created and the way agents are created, which I will show you guys. But so that abstraction is there. So you create an agent, you create a model, and then you do any changes within. It shouldn't matter. People can just use it modularly. But additionally, what's going to come in the tool is the concept of blueprints and data sets. Nothing extraordinary, of course. It's what it is. But what it will allow is these strong models that we are creating, these rich models that we are creating. If we find that there is a schema, if we find there is a template that makes sense in a certain kind of a domain, in a certain kind of a solution, right? Within a company, even generally outside of the community, we could probably give blueprints out and people can just take the blueprints in and kickstart their solution without having to do all the analysis themselves. So that is the other thing that we are looking into. Then we have security first, of course. We are looking at how guardrails can come into picture. We can make sure that it is a policy-driven activity. We are looking at all the different things coming out like Agent Core and other areas to work out identity and identity ideas and try to link it up with the organizations. Because our main aim here is that we are working towards a centralized policy. Can we get a policy at the gateway level such that the agentic flows are driven by policies, are driven by ACLs, are driven in a way that agent to resource and agent to agent, both of those areas can be better managed, just like there is no difference for us between it being an agent or it being a user. And we are able to do that. We are able to do that activity because we are the gateway. So that is the kind of activity that's happening around that space. And then we have EC integration. It's just a small little thing we are putting out there. But the idea is we want to be the gateway. We want to help onboard AI solutions for enterprises. We want them to have a better way of monitoring things. And we do not want to be bound to any one solution. So we are completely agnostic for provider. We are completely agnostic for framework. The agents we are creating today in production, you can run it using ADK. You can run it using Crew AI. On the 18th, I'm coming out with a new release that's going to have AutoGen, LangChain, and LangGraph. And the one after that is going to have strands and other tools. So the whole idea is that we'll keep on integrating tools. And we are setting it up in such a way that the integration is going to be easy. We are using all the frameworks which are general in the market, like OTel, OpenAI, MCP, so that it's easy for people to connect to the workflow that is being created using FlowTorch. Now, smarter decisions through insights and observability. So I've been harping a lot about how it's going to be useful for organizations and how decision makers require this. But I need to really stress on that fact. The biggest concern they have and what makes AI so different from everything, including cloud, is that there is no centralized way to do it, generally speaking. Like there are different solutions. Every single time there's a system of FOMO that you feel this is a better solution, and then Anthropic comes out with something, and then you want to do that, and then Gemini comes out with something, and then OpenAI comes out with something, and you never know what to do. And in middle of all this, the IT team, the compliance officer, the security officer, they're all concerned because what's happening to my data? Where are they going? What is happening, right? So there are two parts that we handle this. One, a very main part, which I'll again revisit later, is that whatever you do with the solution, you can do it in your environment. Our solution, while it is a hosted solution right now, it's also available as Docker files for you to put it into your premise, and you just pay us for the license, right? So that's as simple as that. So it's your keys, your data, your environment, absolutely safe. But the other part is the insights. Because we have traces, because we are centralized, because we know which models are being set up, and because we are making sure all the Gen AI pipeline is going through the gateway, we are essentially able to highlight that these are the insights we're getting from it. So here, for example, if we look at this, it's over a 45-day period, right? This gives people an idea of how much success is there in the pipeline, how much failures are there, what is the input cost, what is the output cost, right? The latency. You can start working on models and decide, okay, some models are too costly, but really not being used at all. Do we really need to keep on paying the provider for that? Right? So these kind of ideas are very useful for decision makers in the discussions that we have had with them, that they find that gives them a relief to see that everything is there in one place. And in turn, it allows them to be flexible towards a developer, saying that, fine, go and play with your tools because I know I can keep an eye on that from this one place, right? And that is why we feel that it's a very important area. Here, for example, we are going to come up with more dimensions. Right now, I'm already working on dimension where you will see the advantage, the cost advantage you get by using caching, for example. So those kind of things are, again, we're trying to work out insights which can give a very, very direct idea to people on what is a good solution and what may be a bad solution. So the same things that we're talking about, we're looking at cost analytics, we're looking at performance monitoring and usage insights. The standard single pane of glass, but still very different because these are all trace driven, these are all AI driven. Now for the builders, most of you, right? Even decision makers amongst you are essentially builders. And what we need to know is what has happened to our call, what has happened to our flow. Like typically, yes, we know it's non-determinism. We are all turning our minds around that saying, okay, let the agent do what it's doing. But somewhere or the other, we want to know. And this is what happens with this kind of trace management that we do with the help of connecting to Hotel, that we are trying to give a waterfall model here. We are trying to give you an idea of where time is being spent. So in this case, for example, provider, of course, is taking the most time, but then your output guardrail and all are taking only microseconds. So then you know it's okay to keep the guardrail. It's not a problem. You can click through it and actually see each span. So now this entire thing is covering 10 span, this trace, but we could click on each of them and actually see the span and try to understand what is happening. So the whole idea is that from a builder perspective, you will have an access, you'll be able to see all the different things that make up the request. You'll be able to see the visualization of the request. And of course, the standard insights is showing the performance and all anyways, which will again give you an idea of where the time is being taken and what are the blockers that are happening. Sometimes it will also give an idea of some things are not even happening. The tool is not being called, or this call is not even going to the second LLM, and those kind of things. Now we come to agents. This is the core of our solution space in today, and all the stuff we are trying to make our agents. And how do we do it in FlowTorch? So smarter agentic for application, yes, it is smarter at conception itself, for the simple reason that our agents are using our models. And all the advantages we were talking about, how our models could give advantage with guardrail and caching and being able to swap in and out and routing, all of that you get out of the box, because as you notice here, the agent details, where you put the agent, you have to put the model. Those models are always FlowTorch models. So if you use FlowTorch models smartly, then you essentially get the heart of your agent is smart. Right? The other thing is the rest of it is just a drag and drop. You're setting up a tool, so you're connecting the tool automatically to the agent. You don't have to go and write about that activity. The agent smartly picks up memory if it's available. It does all the activity around resourcing that way. So all of those things are working out to make it smarter. But the main smartness is the fact that one, it is encompassed here, and two, the model. The model is the FlowTorch model, and that has a lot of smartness inbuilt into it. The second part of smartness is doing things faster for the rapid part that we were talking about. And here we are trying to bring in this Thursday when it gets released, you'll be able to create the agents that you create, and you can just drag and drop them into a prompt sequencing kind of a flow. So in this case, for example, I was just trying out for this tutorial. So we have these 3 agents, and it's just a prompt sequencing happening, right? The thing about the way the agents work here is if I'm just creating a single agent, which is what I'll be showing you later, that agent, we can run it using the ADK, or you can use it Crew AI. We have set it up in such a way that it can work both ways, right? But if you create in the future, at the end of this week, when you create these workflows, these workflows can run from our own execution runtime. So the idea then is that you just give the start of the workflow, you'll get a session ID, then you just query the session ID to get all the messages that are coming out of that workflow. Right? And the next step we are going to go very soon, I think in 2 sprints time, is we are going to come out with a playground where these workflows can get deployed to a playground, and then we can directly click a button and have the runtime happen from UI itself, and no need to go into the code. So generally the idea is, can we make it more and more rapid? Can we make it happen more and more no code kind of way, so not just people who are good at code, but even people who are just putting these agents together can get a way out of with our tool. So I'll just take a moment here to go to the demo, but before that, if I might just ask Hemant if there's any specific question they would want to answer.
No, I think we have answered most of the questions that were asked. I think we can continue with the demo.
Hemant, just one comment here. So some of the questions that they are being routed from YouTube to you. So if we answer them in Zoom chat, only the people who are on the Zoom call will be able to see it. So if you think that there is any answer that you want to address, so because we are live streaming as well, and we have a substantial audience on YouTube. So if you want to, I just wanted to point this out.
No, thanks, Raja. What we'll do is let's continue with the presentation, and towards the end, we'd be happy to take some of those questions that I've already answered here, but I would be able to repeat, and we can take additional questions at that time too.
Sounds good.
Go ahead, Bridge.
Okay.
Yes, so I'm just showing you FlowTorch team. This is FlowTorch I've just created. So let me just show you how this happens. Okay, so one second. So if you go to FlowTorch.ai, which is our site, right? You go to FlowTorch.ai and you get started. And the minute you get started, you have a choice of your cloud platform, right? Now I'll just choose Azure just to show you what happens, but it's the same thing. It's just that whatever your keys are, wherever your keys are from, you can decide that. Today we have AWS and Azure. At the end of this week, we'll have GCP and then Oracle Cloud. So if you create this, we go to the hosted environment. Now this environment is hosted by us so that people can use it, of course, but our expectation is that you'll use it more as a sandbox and for you to try out like what is happening here, how can we do this activity. And our expectation is, as an enterprise, typically people might want it in their own environment because of the data concerns, and that's what we then provide. We'll just provide you the entire solution to be hosted in your environment by you, and we'll just look at the licensing part of it. So when you come here into either the console Azure FlowTorch or the console FlowTorch, you have to sign up. The first person in your organization who signs up essentially becomes the owner of that organization for this activity. And once they sign up, if you sign up from here, you'll go into a verification mode, etc., and you'll come back as the owner of that organization, right? So this is just to show you what you would typically do to join. And when you end up like that, here I am the owner of this organization. So I'll end up in this screen. And this is what we lovingly call the owner screen or the super admin screen. So over here, this is basically dashboard of all the workspaces that constitute the organization. Right now, there are only two. One is a default, one is a sandbox. And these are all the users of the organization, which in this case is just me because I created that. Now, if you are going to add more people into your organization to experiment, this is where you add them. So you will add people here by inviting them using their email ID that you want to use, and they'll get invitations. They will come back to the same sign-in screen, but instead of when they sign up, they will not be talking anything about an organization. There will be a normal member joining in, and all of them will start showing up here, right? Once they show up here, you can create workspaces, and then you can add them to workspaces in the settings here in the members. So that's how typically you would start using the tool, right? So now speaking about the tool itself, again, this is the dashboard of one workspace, the sandbox workspace. Right? And this is just, I've been trying for this tutorial, so it's all happening in this day. But I just created 3 models and I've been trying different things with that. And this is the story of that experiments, right? So now the models that I was talking about, the models you've seen in the code, they're all here. Like the providers are here. These are the providers I could potentially use. They have been set up by the admin ahead of time. So I don't need to worry about it. I don't need to know it, right? They have set it up. They have set up the secret access kernel. I don't need to know that. And then I come to the models and I have got these models, right? The router guarded model is the one you have seen, which is the one where we have the 2 models and the fallback strategy. And then I have got a simple model with caching and without caching. It's a simple GPT-4o mini model and nothing else is there, right? So these are the different ways the models can be created. Similarly, we can create agents. Over here, we have agent builder, right? And for the flow I was creating and I was playing around with the insurance mark agent and all that. But for our purposes, I also created what we have here is the deep wiki agent. So if you look into deep wiki agent here, the typical agent creation will be create a FlowTorch agent, give it a name XYZ, okay, and give a description, enter, and you see this, right? You just start choosing, and that's how you will typically create an agent. But in our case now, for lack of time, let me just go and show you what we had created, which is a deep wiki agent. And the deep wiki agent, I've connected one of the models. Now, if you'll notice here, these models specifically are FlowTorch models. That's the only models you can see here, right? And these are FlowTorch models within this workspace. So you can create different workspaces. You can create a sandbox workspace. You can create a data science workspace, which could have models which are having reasoning, stronger reasoning models there, right? So we have all those choices. Then I'm creating the agent itself, which is for DeepWiki. I'm basically just asking DeepWiki that, okay, tell me information around this repos there and give me the information. And I'm trying to tell them that if you do not find it, please fail gracefully and all of those. And I give a system prompt and I give an agent a goal that this is what I need to do. Standard agent stuff. Okay. And now the tool I attach to it is the DeepWiki tool. Because right now we are only handling MCP tools. We are going to be taking care of your own tools and AI tools also, but right now it's all MCP tools, and we are using the DeepWiki MCP server for that matter. How do we get this? Again, everything is a first level participant here, so we just put tools here, right? We just add the MCP tool here, and we get the tool over here. It's a HTTP streamable one and not necessary. And in case of DeepWiki, it's as simple as that. In some other cases, you'll have a header, etc. Like in GitHub, I think we'll be adding a header. And it's the same thing for everything. We're following the same consistent way all across. So if you see guardrails, right now there's a guardrail I created, right? A redact secrets guardrail. And again, the same thing. I just give a regex and it's been created, and that's the end of that. It's everything follows the same idea that you set it up here, and then you start using it in the larger models, right? Now, how do we invoke this? So if you look at the model, for example, we are giving snippets to give you an idea of how you want to invoke. We have the Python code on how you can potentially invoke it, and we have the curl if you just want to check if the connections are fine, right? Similarly, for agents, we have the same kind, but here, if you notice, not a direct call. We are actually you have to choose. Do you want to do it using the FlowTorch ADK? Do you want to use it using FlowTorch Crew AI? So right now we have got these two. Soon we'll have 3 more and so on. So the idea is that we'll give you the sample code on how to invoke your agent, and then you can make the changes as required. Right? So now using all this code and everything, I have created a collab for the DeepWiki agent. And I don't know how I'm doing for time, but let me just go through this quickly. So here,
Rich, you have time. You have 10 plus minutes. I mean, take your time.
oh, cool. Here. So yeah, so we are going through this agent setup right now. So, okay, we have got time. Let me just show you a quick check here on model, right? So you have the model check. I told you about the model activity, etc. So here's the model. It's just installed some time ago. This is the FlowTorch SDK. And then I import the model FlowTorch SDK here, and I'm using the model here, right? This is the routed guarded model I showed you. Okay. And the trick with the routed guarded model was this thing of SK dash. I was treating SK dash as some kind of a secret, right? And I'm telling it that redact that. So yeah, you've seen that it ran. Let me just do it again anyways. It's not going to take a long time. But the whole idea was that we do this activity, and now this is happening because I have a guardrail there with a regular expression. So my normal question is capital of Norway, yes. But then it can't do anything more than that because of the redacted. Right? And the idea is that it is saying this is the SK, whatever is the redacted part, and I cannot do the activity. Right? And this is, of course, a very, very trivial regex I created, but then we can pull any guardrail. In fact, we are right now working on pulling in NVIDIA guardrails also. So the idea is that you can combine these guardrails. You can have models where you have NVIDIA guardrails and you're having models from Bedrock, and you can put it all together as per your need and not necessarily get constrained by how the providers are providing stuff. Yeah. Now coming to the DeepWiki, here we are doing the ADK package installation, which is basically the FlowTorch with the ADK part of it. And then we are setting it in the ADK mode. All right. So we are getting all the libraries and setting it all up. And the only thing we're really setting up is the agent name. And these two connections are to the gateway. Right. And this user ID and app name is generally used for the tracing part of it. And then we have the remote agent. Then we create the runner, the interactive chat for that, and then our question, right? This is what I was trying, like tensor, we were trying for repository of PyTorch, let's say TensorFlow. So this agent is now basically the one I just created, and it's utilizing the ADK setup to be able to run it, to run the agent. Okay, so we ran this now. Good enough. It works fine. We have just followed what ADK asked us to follow, so that's good. So like I said, the whole idea here is that for people who are doing the development, there is no difference. They're just doing it. They may have to write some little bit of less code, but essentially they're using the stuff. What makes sense for us is back here. Now we ran that, and we're coming back here, and if you look at the logs now, right? And all those timings are in UTC, so that's a matter. But right now, if you see, you have a 9:52:51 log happening here, right? And if you look into that, now there's a log which has happened, right? So there's a provider log which has happened at this point of time. But if you look at this time, 52, there's been calls before that because this is the agent, so it's making multiple calls. So actually, the call started here. And at this point of time, there was a tool call. There was a tool call which happened, which explicitly shows that what are the things happening out here, right? And then after that, we also have the tool itself calling the MCP server. This MCP procure request and the tool is happening here. And again, we see how much time is going in that, right? So the idea is that our developer as well as people who are observing, we are able to come back and we can check things at this level because, of course, the system is there. Everybody is playing good and we are writing all of the stuff happening around this traces to do the activity. But we are able to show it in this way, right? So this is, and then you can go to any span and you can check the spans also. So yeah. So that's how we are able to set up an agent as simply as that and run and check the logs. Hemant, am I missing something before I go away from our tool?
No, this is good.
Yeah, fair enough. The API documentation is here. Let me just show you one more small thing before I go away. If you go to FlowTorch.ai, here we see this GitHub. That's pointing to a comparatively very new repo that we have created called resources, which has got some examples. Right now, we have got examples around ADK, CrewA, and SDK on how to use this with FlowTorch. I promise you, we'll have a lot more stuff here. So keep this earmarked. And if you have any ideas on how to add some stuff there, please send it out to me. Right? I'll make sure we add them here. The whole idea is that we want this to become a repository of useful code for everyone to try out new things. Yeah. Now, let me go back to the PPT. Yes, I promise you a quick demo. This is the final part. Okay. The cloud that I showed you is basically for you to try out. Okay. We are giving 1 million requests free. Essentially, 1 billion, around about 1 billion token is completely free, which means there's more than enough free tokens available from our side for our part of the activity, right? That you can use up. So it's basically, for all practical purposes, free for you for at least a couple of months plus for you to try out your different things. And while you're trying those different things, if you feel like you need a little bit more help or you need a little bit more time, just reach out to me or Hemant and we'll make sure you get that. The whole idea is that we want people to try out the tool and see the advantages they get out of it, right? And if they feel right, then like I said, in some cases, yes, they might still be on the tool, but for most cases, you might prefer to have it in your environment and we'll make that happen. So it will be on your premises, with your data and your information. So that's the general idea. But at this point of time, absolutely feels fair to scan and go.
Brijesh, there is a question that has come up as to, hey, what kind of different cache storage options are available? How many days can it be stored for? So if you don't mind sharing the screen and showing people for, say, simple caching or semantic caching, what are the options available and how they're configurable? Thank you, Anshuman Bhaumik, for that question.
Yes, I'll show you. So if I go here and I go to cache, so we have simple. Oh, wait a second. Let me just go to the other one. Yeah. So we have simple. And right now we are having it on a very minimum 500 tokens initiates the need for a cache. Anything less than that, we feel, okay, it's not worth it, right? Because we are 1500 is like minimum in normal chat bot kind of interactions. So this is the kind of minimum tokens we are putting in place right now, but we are thinking of moving it slightly into more of a scale, right? How long can we keep? 7 days, 15 days, 30 days is what we're doing right now, right? Again, we are thinking on it whether it can be more or less, but our worry is if we keep it too much more, that could also have a constraint on your team with cost of the cache, right?
Right. So there was another question that was asked about that hey, if it is cached for too long, will it start hallucinating because it's a cache response for a old query? But that's why you get to choose these settings and control it within your parameters.
Yes. And then the maximum number of items is, of course, straightforward. And then the other cache we have is semantic, but the parameters are the same. The other caches that we are going to come out with, the time-based one. Sorry, that's a router one. Yeah. Yes. So that answers the question.
So yes, it does.
Of memory,
and
just
actually,
sorry.
Yeah, if you don't mind talking about the routing, because that's also interesting for many people. There are 3 different options there that you talked about.
Yeah. So one is, of course, fallback, which is just fallback, and round robin, there's nothing, it just goes around. In weighted, the idea is that you can give it some weightage. Like in this case, maybe I'll give a lot more weightage to GPT-4 or Mini, but some offhand cases, 20% times go to OpenAI GPT or something I can set up. Now here, it's keeping it equal 50-50 because it's just come up as it is, but we can change the weightages here. Okay. But these are still simplistic ones. We're going to come out with a time-based one, which could work in conjunction with a round robin. So it could be round robin and a time-based one, right? That kind of a combination can happen. And the one that I'm really excited about and I'm working on is the dynamic AI routing, where we could start looking at the query and smartly highlight which LLM or which class of LLM or which body of LLM would be best suited to answer that, right?
Right,
So
right.
that will be very
Anthropic
dynamic also.
Anthropic came out with a study that shows that 68% of the queries are simple queries, like the example you showed, right? What is the capital
Yeah.
of this country, or who was the particular person who won the gold medal in Olympics in certain year. So these questions can be answered by smaller models like GPT-4 or Mini, or any of the kind of a Nova Micro, Nova Lite, for example, or Gemini Flash, much faster and cheaper, versus some of the reasoning tasks need to be answered by larger models like GPT-5 or Nova Premier or Gemini Pro, and so on.
Yep.
One of the questions that I got on the group here was about how do enterprises, where do you see enterprises kind of trying to strike that balance between control and at the same time innovation? How do enterprises strike that balance, the decision makers? Brijesh?
So the way I see it right now, the biggest problem enterprises have is this. Most top enterprise people most decision makers want AI and they want it today. But the problem is that many times the biggest advantages AI gives are not tools that are part of their daily routine at work, right? So many companies are actually putting in this effort where those people are working and they are getting kind of a 180 degrees demos. They're being taught by the youngsters on what are the stuff AI can be helpful for. So that's one thing, that they want things to happen, but they don't really know. And because they don't really know, they don't want to lose control. The second thing, and the more important thing, is more from a compliance and security perspective. What they're saying, they're not trying to become difficult. They honestly have a problem. Like, is it okay just to send things around? And our answer there is that if we have tools like this, if we have tools which allows them to monitor if everything goes through that this gateway, right, and they can see that, that will give them more than enough comfort to just sign off, because they all understand that they need to get AI ready very fast. The concern is that they cannot decide that they cannot take a risk without having some idea about managing that risk.
And maybe on a lighter note, Bridge, I mean, keep InfoSec and legal away from the prototype proof of concept as much as possible until you have something very meaningful. Because if you involve them early in the process, they are going to freak out. They are not going to actually let you.
That is one, Raja. And the other challenge is also, while we want to keep them away, think of it from decision makers' point of view, right? At the end of the day, if it has to go live, it has to go through that process. But why not set up these tools like FlowTorch Gateway, where you have those guardrails in place, and then get out of the way of innovation? Let Gen AI engineers build the best prototypes and innovations that they can for that organization. Because at the end of the day, you can still add the layers of guardrails or caching or even memory utilization and token tracing and tracking as per your need and policies for the organization. So that's a great flexibility. You can use it to your cursor, windsurf kind of tools, and not be involved at all. All models that you're accessing from Anthropic, for example, you can still access through cursor, but just go through the gateway and it will be as per the norms. Or you can use SDK, or you can use the drag and drop tool.
Yeah. From our experience, Hemant, what has happened is that the InfoSec and legal, they don't quite understand the the nuances and the complexities of how Gen AI works.
I know.
And sometimes they can
Yes.
actually start worrying too much about things, right?
So what I have
Yes.
done with InfoSec, right? I used to have this problem even in the cloud days when Oracle started supporting from externally, right? I'm having an Exadata box and they'll support only externally, and that means they need to tunnel into my system, right? So the only way I convince them finally is this, that they'll tunnel into system, but the minute they start tunneling, it's all recorded and monitored by us. At any point of time, I have got a logging solution which you can query and you can find that out, right? That once you give that kind of a thing, at least they'll say, okay, we'll try to play good with you. That, and the other thing is, let's make them a legal agent. That will make them happy.
Yes.
So yes, please do feel free to follow us on FlowTorch.ai. Yeah, I am there on LinkedIn. Hemant is there on LinkedIn. Feel free to get in touch with us. And any ideas you have around AI, please feel in touch with us again. We are interested in researching general stuff also, not just around FlowTorch. So more than happy to interact.
Okay.
Yes. Any other
Okay, then.
questions?
Thank you so much, Bridge. If you and Hemant, both of you are done, then
Thank you.
that should be it. That should be the end of the session, and that also ends the second day of the conference. Thank you so much, Bridge and Hemant. This was very, very helpful. So
Thank you, guys.
Where are we? We are on the end of second day. The remaining 3 days are actually workshops. We did share the links to the workshops, and those are some of you have asked, but those are actually paid workshops because of the the logistics and the infrastructure and some of the things. They are more deeper dives. So they are unfortunately paid workshops, but we will continue. Actually, we will again bring back the Agentic AI Conference in a couple of months, and I will bring back more topics, anything that has evolved by then. The technology is actually changing so fast. I mean, it is very hard to keep up. What I would like to do here is, before we close the second day of the conference, I would like to, actually, I'm on screen too. So I would like to just let you all know, we are actually the first bootcamp in industry on large language models and agentic AI, and we are probably the one with the highest number of graduates. We offer this bootcamp in collaboration with some of the leading names in industry, VV8 on vector databases. LangChain is a partner, VV8 is a partner, Arise is a partner on the observability and monitoring side. And then we have a few other names I'm actually blanking out right now. So if you are interested, this bootcamp, and we also offer this in collaboration with the University of New Mexico. What that means is that if you are working for a company that reimburses tuition for any kind of course, any kind of certification, any kind of academic learning from a university, you may be eligible for your tuition benefits, and you can use that toward the Agentic AI Bootcamp. We cover all the things in a lot of detail, starting, you don't need to be a coder, of course, I mean, being able to read and understand code, but you don't have to be a developer. We start with all the fundamentals, starting from transformers, attention mechanism, all the way to vector databases and embeddings, and, agentic RAG, semantic search, hybrid search. We dive into LangChain fundamentals. We talk about LangGraph. We talk about all the React, reflection pattern, React pattern, Kodak, some of those design patterns for agentic thinking. We also talk about evaluation of agents. So it's a fairly comprehensive course. Go check it out and see if you would be interested. The next cohort is starting. We have 2 cohorts. We have a lot of demand, actually. We just finished our last cohort. That was a morning cohort. One request that we got was, we are in a different time zone and this time does not work. So we have 2 parallel cohorts that will run. The first cohort is a morning cohort starting on September 30th. And another one is the October 9th cohort. This is online, 3 hours a week for 10 weeks. And then and then there is, of course, some more work that you will be doing at your own pace. Yeah, go check it out. And then if you have any questions, feel free to reach out to us. With that, for those of you who are joining workshops, we'll see you again tomorrow. For those of you who are not going to be there for workshops, thank you so much. Please send us feedback. Tell us which topics you would like to see in the next conference offering, and we would be happy to create a schedule that actually is a meaningful learning experience for all of you. Thank you so much, everyone.